Hey, this is Juan Tutors, and today we are working on the June 2025 Algebra 1 Regents. For me, it's the most recent Regents. If you're watching this video between June and August 2025, it's also the most recent Regents for you. I haven't heard a lot of complaints about this Regents, unlike, for example, the biology and the Earth and Space Science, which I haven't done the videos for those yet. So I'm going to tell you my feelings about those tests when I record those videos. That said, not a lot of complaints from teachers, not a lot of complaints from students. I think this has been a pretty fair test. Um, I'm pretty excited about it. The one piece of advice that I'm going to give before even getting to problem one, which is right over here, is that you should treat the part ones the same way you treat the part twos, threes, and fours, and you should treat the part twos, threes, and fours the same way you treat the part ones. And now, what does that actually mean? What that means is you have to show work for both the part ones and the part twos, threes, and fours. And I'm gonna show you along the way why that's true. But the big reason is when you look at the part twos, threes, and fours, you're gonna find that the part twos, threes, and fours are exactly like part one questions, just that they don't have multiple choices. And similarly, the part one questions, which are multiple choice questions, can very easily be converted into a part two, three, or four question by just removing the multiple choices. Now, none of the part one questions all by themselves can be converted into a part three or four, but it can be converted very easily into a part of a part two, three, or four by removing the multiple choices and maybe doing a rewording of the sentence, just like in problem one, which just ends in the middle of a word. Rewording, basic rewording. That said, that's the big advice, and I will be giving more advice along the way. The purpose of this video and the way I do it, first off, it's long form. The reason it's long form is so that you could see my writing a lot more easily. The whole video is gonna have every problem done, but not only is every problem gonna be done, but for all the multiple choice questions, I'm gonna give you advice on not just getting the question right, but at first, how to eliminate any incorrect answers. For example, using very good strategies for process of elimination, just in case you're the kind of student who's like really struggling to get that 65, and maybe you do get a 65, but you're really struggling to get the 80, or maybe you are actually great at getting the 80, but the 90 is really your goal. Or, you know what? You're watching this video because you want to get that 100. And there's always just this weird question that you get up to that you don't know how to do. Sometimes eliminating answers is equivalent to getting the answer right. And there are going to be a lot of problems, and you'll see that there's going to be a lot of problems that you could actually eliminate every incorrect answer. And what's the difference point wise between eliminating all the incorrect answers versus calculating correctly the right answer? Point wise, there isn't a difference. Point wise, they're exactly the same thing. So what we're going to do, even though there is a better value in knowing how to do the problem uh, from basic principles, because of the fact that part twos, threes, and fours require that, you're going to see that strategies for process of elimination are going to be very, very helpful. On that note, we are starting number one. The expression 10 over radical 2 is equivalent to 5 or 20 or 5 radical 2 or 10 radical 2. Now, this is a great example of a question that you do have to know how to work on a part 2, 3, or 4. So we do have to make sure that we do this question correctly from first principles. But in terms of being a question, can we do this question on the calculator? I mean, 100%. So if you know that division by a fraction in a fraction format, horizontal fraction bar, is equivalent to the diagonal fraction bar or the division, as long as you use grouping symbols, then you could just use the fraction bar. But I'm gonna on this very first question, I'm gonna show you how to enter fractions into the calculator with a horizontal fraction bar. And a lot of teachers don't even know that that's possible. So much less a lot of students. So 10 over radical 2. Ooh, what just happened there? And by the way, any errors that I make, I'm basically keeping them in the video. The reason I keep all my errors in the video, just like the one you saw me make with a button, is that students request me to do all the regents. And I've noticed that I spend so much time with the editing process that I end up not even doing the regents. I end up skipping half or more than half of the regions. Sometimes I only get to two because the editing process takes maybe 3 times as long as recording the video does. So I don't edit any of the videos. I record from beginning to end, and then I post. Okay, that said, 10 over radical 2, it tells us this as a decimal, 7.07. Now, that's clearly not equal to 5, and that's clearly not equal to 20, so we can immediately eliminate that choice 1 and that choice 2, so we know this is now a passing problem. And in fact, if you work with a little bit of your intuition, you might realize that this one seems to make sense, and this one seems to not make sense. Now, why does the bottom one not make sense? That the bottom one would be equivalent to saying that dividing by radical 2 is the same as multiplying by radical 2. The only number you could divide by and multiply by and get the same answer is just the number 1 or -1. Divide by -1 or multiply by -1, you get the same answer. Divide by 1, multiply by 1, you get the same answer. Divide by radical 2 and multiply by radical 2, you get different answers. So a fake student me might be saying, well, I think that this is wrong. I suggest to you, borrow my notation. I knew that problem 1 was wrong, so I crossed it out. I knew that problem 2 was, choice 2 rather, was wrong, so I crossed it out at the choice. Fake student me suspected that choice 4 was wrong, so I put an X next to it. I didn't cross it out. I didn't cross it out at the number though, because fake student me was not sure, and fake student me suspected that choice 3 was right, so I put a checkbox next to it. I would circle it if I was 100% sure. And based on my wording, I already actually can confirm really that choice 4 is incorrect, because what I said was dividing and multiplying by radical 2 are different operations. They give you different numbers. So 10 divided by radical 2 and 10 times radical 2 have to be different numbers. So I'm gonna plug in 5 radical 2 into the problem, into the calculator, and it does confirm to me that 5 radical 2 is the correct answer. Real quick, I just want to show you how to put a fraction bar into the screen. You press the math button, go to the right to number, and go to the very last option under number is n over d, and you could put in 10 divided by radical 2. And so you could have done it that way, and you would have gotten the same 7.07. So calculator confirmed that choice 1 was the right answer. Choice 3 rather was the right answer. But we do need to know how to do this one on first principles, because we can't focus on just the part 2s, 3s, and 4s. And I'm going to give you 1,000 reasons why that's true along the way. So how do we do this problem on paper? And by the way, this is a skill that was not tested for in Algebra 1 during previous Regents. So this is actually technically a new topic. 10 divided by radical 2. I'm going to multiply the numerator and denominator by radical 2. Okay? And I get the numerator is equal to 10 radical 2. And that's divided by radical 2 times radical 2. You do need to know that a radical times itself is equal to the radicand. So radical 2 times radical 2 is just 2. Another equivalent statement is that the squaring operation and the square root operation are inverse operations. So so radical 2 times radical 2 is radical 2 squared. The radical and the square cancel, leaving you behind that 2 that's inside the radical. And now I could divide by 2 in the numerator and denominator. So I divide by 2, and that cancels out the 2 in the denominator. And now in the numerator, this divide by 2 cancels, and you're left with a 5. And so then this is equal to 5 radical 2. And so that is our answer on first principles. You're going to see that there is a part 2 question that does require us to know how to do what we just did. With that, we hop right to number 2. A parabola is graphed on the set of axes below, and we see the parabola right here. And then we ask the question, over which interval is the parabola only increasing? Only increasing. Is it the closed interval from 1 to 4, or the closed interval from 3 to infinity, or the interval from -infinity to 3 inclusive, or the closed interval from -1 to 1? And then they said only increasing, only increasing. So this is one that you can do just taking a careful look at the graph and deciding where it's increasing, if we go from left to right, the function, so this is important to know that this has to be left to right. You don't have an option on what direction you move when you're thinking about increasing or decreasing. This is left to right. You could call this lexicographic order, or you could call this reading order in the United States, and in English specifically. It's not just the United States, it's many languages, not all languages, but the English language, the Spanish language, Portuguese, a lot of languages we read left to right. And so when we're talking about increasing only or decreasing only, we're also talking only left to right. So if you follow the function, it's definitely decreasing. And it's definitely going upward here, it's increasing. So anywhere where it contains points where the function is decreasing have to be wrong. So I see that the vertex here is at the point 3 comma negative 4. That's where the vertex is. So increasing has to be to the right of x equals 3. Has to be to the right of x equals 3. And what is to the right of x equals 3? Let's see, 1 to 4. 1 to 4, I don't know why that happens. 1 to 4 contains, so 1 is to the left of 3. So that's wrong. Here, these are all to the left of 3. So that's not it. And then negative 1 to 1, this is also all to the left of 3. So that's also wrong, leaving this. And this is actually the entire region that's to the right of 3, including 3. 3 and everything to the right of 3 is the correct answer. So we got the answer to that one. And that one just took knowing that we're increasing from left to right. That's all it took knowing. Number 3, which scenario represents an exponential relationship? Is it Kristen's New Year's resolution is to lose 1 pound each week? Or Sarah wants to increase her grade by 5 points each quarter? Or Tommy wants to reduce his spending by $50 each month? Or Dylan hopes to grow his business by 5% each month? So this one clearly has something to do with growth rate or shrinking rate. But it's important to know the relationship between how linear functions work and how exponential functions work. So linear functions, so now before that, can we do this problem by eliminating some choices? And we actually can do it by eliminating some choices, even if you don't really know how exponential functions work. The reason you can do that is that some of these scenarios compare to each other structurally. For example, I see number 2 and number 3. Sarah wants to increase her grade by 5 points each quarter, and also Tommy wants to reduce his spending by 50% each month. These are the same model. For you're either adding 5 points after each amount of time, or subtracting $50 at each step. So because they have the same numeric effect, they have to be the same model. Since this is a multiple choice question, they can't both be right. Therefore, they both have to be wrong. Now the question is, what about the Kristen's New Year's resolution is to lose 1 pound each week versus Dylan hopes to grow his business by 5% each month? You may realize that one of these two also has a similar model as number 2 and choice 2 and choice 3. Let's look at choice 1 first. Kristen's New Year's resolution is to lose 1 pound each week. And I'm going to say time. I'm going to make a time column and a weight column. Now, I don't know Kristen. Kristen is a fictitious person, so I'm going to use my weight right now. I do happen to have a goal of weighing 195, but right now my weight is 215. So that's actually not the time. This is week 0. I weigh 215. So if I am following Kristen's New Year's resolution, then on week 1, I'm going to weigh 214. On week 2, I'm going to weigh 213. On week 3, I'm going to weigh 212. Notice that I'm subtracting 1 at each step, which follows the same model as choice 2 and choice 3. And this is actually an important feature of linear functions versus exponential functions. So in linear functions, we iterative, so we could say it using some big people language, iterative, E-T-R-A-T-I-V-E-L-Y. So iteratively add or subtract a fixed number at each step. For weight, subtract 1 pound every week. Week 1, subtract a pound. Week 2, subtract a pound. Week 3, subtract a pound. Or increasing points each quarter. Quarter 1, add quarter 1, add 5 points. Quarter 2, add another 5 points. Quarter 3, add another 5 points. Quarter 4, add another 5 points. Or reducing spending by $50 each month. So my spending for this month, the next month, in January, I subtract $50 for my spending. February, I subtract $50 from my spending. March, I subtract $50 from my spending. Continuing that way. I'm adding or subtracting a fixed number, whereas choice 4, if you notice in choice 4, we are growing the business by 5% each month. The way you do this, so there's a time coordinate, and then there's the business size. So I'm going to say, let's pretend that the business size is 1,000 on month 0 or month 1. Or let's say month 0. Then on month 1, I got to grow it by 5%. How do I increase the 1,000 by 5%? You could calculate what 5% is and then add it to that, but that's not, there is another way to add 5%. You could multiply it by 1.05, which is actually in this case 1050. Okay, and in month 2, I multiply the previous month's business by 5%, so that's 1050 times 1.05, which ends up being 1,102.50 cents. I'm doing that in my head. I think that is right. Yes, $5.250. Yes. $1,102.50. So notice that I'm iteratively, so and this is how exponential functions work. So exponential functions, we iteratively multiply by a fixed number. So multiply or divide by a fixed number at each step. In this case, we're going to multiply by 1.05, then multiply by 1.05, then multiply by 1.05, then multiply by 1.05. So on week 3, it would be 1102.50 times 1.05, multiplying by 1.05. That is what exactly choice 4 is doing. So choice 4 is, with 100% certainty, a exponential function. Number 4, the geometry test scores for Andrea and Joe are shown in the table below. And I do take a quick look at the table before going back to it. I see Andrea 82, 87, 90, 84. And I see Joe 91, 78, 94, 67. And then the question is, which statement about their test scores is correct? Both the mean and the standard deviation of Andrea's test scores are higher than Joe's, or both the mean and the standard deviation of Joe's test scores are higher than Andrea's, or the mean of Andrea's test scores is higher than Joe's, but Joe's standard deviation is higher than Andrea's. Or the mean of Joe's test scores is higher than Andrea's, but Andrea's standard deviation is higher than Joe's. This is the problem where I get to talk about what a 2x2 problem was. And I want to give a shout out to all the people who commented in my previous video on how helpful thinking about a problem as being 2x2 was to increasing your score. So what's going on with what I call a 2x2 problem, and you don't have to draw this diagram. That's another beauty of it. You don't have to draw this diagram. When you're reading this problem, you might be saying to yourself, this problem is entirely too complicated. It is not worth my time to do it. It's also a lot of reading, and you may also think that the problems with more reading are actually more difficult. Fun fact, not only is that not true, the opposite is true. The ones that are shorter tend to be the more difficult ones. That does not mean you should skip the shorter ones, because you may find that you could actually do them, but the longer reading ones tend to be the easier ones. And the reason is that they have to factor in how long it takes to do the problem. So the longer it takes to read it, the less time it should take to do. And that's 95% true. So now let's look at this. This is comparing Andrea's mean and standard deviations to Joe's mean and standard deviation. So we could actually make a 2x2 table considering first whether Andrea's mean is higher or lower, and also whether Joe's mean is higher, and then whether Andrea's standard deviation is higher or lower. So Andrea mean is higher, or is it lower? And then Andrea's standard deviation, is that higher, or is it lower? Now, according to the problem, choice 1 says that both the mean and the standard deviation scores are higher. So what that implies is that this is problem 1. Choice 2 is that both the mean and standard deviation for Joe's test score are higher than Andrea's. So Andrea's mean and standard deviation are lower. This is choice 2. Choice 3 is that the mean of Andrea's test score is higher, but Andrea's standard deviation, Joe's standard deviation is higher, so Andrea's standard deviation is lower. This is choice 3. And finally, choice 4, the mean of Joe's test score is higher than Andrea's, which means Andrea's mean is lower. And then also her standard deviation is higher. This is choice 4. And so what we can do, the beauty of it is that we can actually now think about the mean and the standard deviation separately. We could think of the mean and the standard deviation separately. So for example, I'm noticing that Andrea's test scores are all clustered between an 82 and a 90, and there's not a lot of variation between them, whereas Joe's standard deviation, Joe's scores range from 67 all the way to 94, and they're actually very spread out. And as I remember, without calculating it, I remember that a standard deviation is a measure of spread. A standard deviation is a measure of spread. So this implies that Joe's standard deviation is higher. And then Andrea's standard deviation is lower. So just by looking at the spread, which means, let's see, Andrea's standard deviation is lower. That is a checkbox here and a checkbox here, and a cross out of choice 1 and choice 4. That's a big deal. We've now got a passing problem. Again, this is the 4th passing problem, I believe. Because in every other example above, we were able to eliminate 2 incorrect answers or even 3 incorrect answers. So yeah, so this is a passing problem. So, and I haven't yet explained what a passing problem is. I don't want to explain everything on every problem. So we'll explain a passing problem later on. But now we can look at the mean. The mean is the average. We add up all the scores and see what they average to by dividing by how many scores you have. Let's see. Let's see if I could scroll this way. Perfect. So you could see this test. And so I'm gonna calculate. I'm actually gonna use this chance again to show you the fraction entering. Math button. Go to the number column, the very last option, n over d. I'm going to add Andrea's scores, 82 plus 87 plus 90 plus 84 and divide by 4. I feel like Andrea's average is going to be higher, but I don't know yet. And her average is 343 over 4. I need to convert that into a decimal. So math arrow decimal. Okay, math convert to a decimal, 85.75. So the mean, her mean is 85. Wow, that's a terrible 8. 85.75. And then Joe's mean, let's see, do the same fraction. Again, so just to do it again one more time, it's gonna be press the math button, go to number column, the very last option, N over D. And I'm gonna do the 91 plus 78 plus 94 plus 67. A nice little trick to make it into a decimal before the calculator makes it into a fraction. If you want to write it as a fraction, but despite that you want it as a decimal, make just one of the numbers into a decimal. And then divide that by 4, and I get 82.5. So his mean, Joe's mean, is 82.5. So which mean is bigger? Clearly, Andrea's mean is bigger. We're going to put a checkbox next to the two answers that have Andrea's mean is bigger. I'm going to cross out the ones that have Andrea's mean lower. So the only one that has two checkboxes is choice 3, which leaves choice 3 as the correct answer. Number 5, which polynomial has a degree of 3 and a leading coefficient of 2? Is it 2x squared plus 3x plus 1, or is it 6x cubed plus 3x squared minus 2x, or 3x squared plus 2x plus 2, or 2x cubed plus x squared plus 4x? Now, I think this is the kindest of this type of problem that they've ever given. They often do give a tougher problem than this. But this one is having a look for a degree of 3 and a leading coefficient of 2. Let's just remember the leading coefficient is equal to the first coefficient when in standard form. The polynomial is written in standard form, i.e. decreasing exponent order. And if you notice, all of these are written in decreasing exponent order. Choice 1, 2, 1, 0. Choice 2, 3, 2, 1. Choice 3, 2, 1, 0. Choice 4, 3, 2, 1. So they're already written in decreasing exponent order. They didn't even scramble the terms. They always scramble the terms, except this one test. I don't know. They maybe wanted this test to be easier for some reason. There are a lot of things that have happened along the test that they made the problems just a little bit easier for this test. I don't know if that's going to continue as a pattern. I don't want to give you a false sense of hope. We won't know what the August Regents is going to look like until they give the August Regents. And there's theories about what the August Regents looks like, so we don't want to judge based on that one either. We will know when the January Regents and then the next June Regents come, so we'll know in a year. That said, a leading coefficient of 2, this one has a leading coefficient of 2, this one has a leading coefficient of 2, this one has a constant coefficient of 2, and this is not the leading coefficient, nor is it the constant coefficient. This one has a leading coefficient of 6 rather, and this one has a leading coefficient of 3. So that's not it either. But now let's look at the degree. The degree for choice 4, this is degree 3. That's the exponent 3. This one is degree 2. So that one's wrong. Choice 4 is the only one that has satisfies all the conditions with 2 checkboxes, the leading coefficient of 2 and degree of 3. Number 6, the expression parentheses negative 3x squared plus 9 close parentheses minus parentheses 7x squared minus 5x plus 4 close parentheses is equivalent to negative 10x squared plus 5x plus 5, or negative 10x squared plus 5x plus 13, or negative 10x squared minus 5x plus 5, or negative 10x squared minus 5x plus 13. This is actually a 2x2 question if you wanted to explore it that way, because they all have a leading coefficient of negative 10, but the linear coefficient is either plus 5 or minus 5, and then the constant coefficient is either 5 or 13. And so the question can be boiled down to question 1, is the linear coefficient 5 or negative 5? And then question 2 is the constant coefficient 5 or 13. That's great. So if you wanted to explore the problem that way, you could probably get the question right that way. Like I already suspect, I already know that the linear coefficient is going to be positive 5, because the first polynomial, negative 3x squared plus 9, doesn't have a linear coefficient, so its linear coefficient is 0. And then we're subtracting the second polynomial, so we're subtracting negative 5x, which is equivalent to adding 5x. So the ones with negative 5x in them immediately can be marked as wrong, and the ones that have a plus 5 as the linear coefficient can be marked as right. Now we have a passing problem, which every single question so far has been converted into a passing problem, PP. I might just write PP in the future for passing problem. I've never had a test where I was able to just show some method where every single question was a passing problem, and I don't remember if that's what this one is right now. But the fact that the very first 6 questions were all passing problems is a hint that this test is slightly easier than most have been. But let's talk about what a passing problem is now. So if we go to the scoring key, this is not the scoring key, the conversion chart for the Regents. The conversion chart tells us how to convert the raw score on the Regents into a scaled score out of 100. There are a total of 82 points that can be received on the test out of 100. Let's see. Can I move this around? I think I made a mistake there. Let's see. This is going to let me move it around. Okay, so the total number of points that we can get is 82 out of 82 points, and that would give us 100. The lowest score that we can get every single question wrong, although statistically speaking, that's almost impossible. But that would give us a 0 out of 0. Wild guessing on the multiple choice gives us 6 on average. This is like if you just guessed choice 3 on all the questions and didn't even bother with the test. That would give us on average 6 out of 24 questions, 6 questions correct on average. Multiple choice questions are worth 2 points each, so on average 12 points, which gives us a 45. So wild guessing is a 45. Not bad. And you might think that that's actually pretty close to a passing grade of 65, which is 29 points. That's half points more. It's 12 or 13. It's actually just shy of 15 questions. So we're going to stay saying 15 questions, although really it's kind of like 14 plus a point somewhere else, or 13 plus 3 points somewhere else, or 12 points, and this is relevant, 12 points and 3 points somewhere else. I'm sorry, 12 questions and 3 points somewhere else. And because that would give us, 5 points somewhere else. Yeah, sorry. 12 questions, 24 points, plus 5 points somewhere else. So you might think that that means that we could just focus on the multiple choice. And that's actually one of the reasons why teachers give that advice. And teachers, I love you, but if you do tell students to only focus on the multiple choice, I do think that you need to expand your explanation of that a little bit more, because it needs better clarification. The way you focus on the multiple choice is by showing as much work as humanly possible on the multiple choice. And we learn that when you do that, actually you start getting a lot of points on the part 2s. When you do as much work as possible in the part 1s, your grade doesn't go to a 65. Your grade usually goes to an 80. So that said, why do I call a multiple choice question where we've eliminated 2 choices a passing problem? technically speaking, you need 14 and a half multiple choice questions to get right, which is so close to 12. And like I said, you get a little points here and there on the part 2s, 3s, and 4s somewhere else. Then you actually can handle passing the test with just 12 questions. And 12 out of 24 questions is half the multiple choice. So if you take a question and you eliminate two 100% incorrect choices, you now have a 50-50 chance of getting it right, even if you wild guess. And if you do that with all the questions, then statistically speaking, they lead you to a passing grade. They don't give you any extra credit beyond a passing grade, and they don't give you, on average, cause you to lose points beyond below a passing grade. Statistically speaking, they keep you right at the passing level. So getting to the point where we could eliminate two choices that are 100% incorrect is super valuable. And we see that the methods that we've learned so far sometimes eliminate three choices, which is even better, because then you have a 100% chance of getting the question right. Not for nothing, if you eliminate one choice, then you have a 1 in 3 chance of getting it right, which is still extremely valuable. So eliminating answers that are 100% incorrect is actually extremely valuable. That said, that's why when you eliminate two incorrect choices, that is a passing problem. And I just did that by the 2x2 question. I knew that the linear coefficient had to be +5 and not -5. That said, how do we do this one the way we would do it on a long answer question, part 2, 3, or 4? We would distribute the negative sign. That's equivalent to distributing a multiplication by -1. And so then that would, and then here we could distribute a 1 if that's what makes you comfortable. +1, when you distribute a +1, we get -3x squared plus a +9. Now we're going to multiply by -1. A lot of students like keep, change. In this case, keep, change. Okay, so if you take this negative sign, change it to a plus, and then change everything else plus minus. So it's for some reason easier to track for a lot of students. So -7x squared plus 5x minus 4. And now we look at the coefficients one at a time. 3x squared minus 7x squared. No, sorry, -3x squared minus 7x squared is equal to -10x squared. So now we know we're on the right track because all the choices have a -10x squared. If we did this wrong, we would have gotten something else. So we're on the right track. And now we have a plus 5x. Well, 5x, that's done. 5x. So that's right. That already confirmed what we had suspected from just looking at the linear coefficient. And then we have the constant coefficient. 9 minus 4 is equal to 5. And that leaves not 13, but 5 and 5. And the only one that has two check boxes is choice 1. And so choice 1 is the correct answer. Now I'm putting my logo everywhere on the screen because my tutoring website is JuanTutors.com. I do tutor professionally. And so if your parents are interested in getting tutoring from me, please do have them visit JuanTutors.com. And by the way, in the description of the video, I also have a link to practice problems, a shortened version of the document of the types of problems that are needed to pass the Regents. Okay. A lot of students ask for that. A lot of teachers ask for that. A lot of parents really ask for that. So I do have a document that helps to reduce the amount that you want to cover if you just want to cover a smaller number of things. And that's free, by the way. And the reason I do these videos for free is literally just to make a part of my business accessible to people who grew up like me, who can't afford the prices that I charge. Okay. And I do have other tutors that charge prices that are lower than me, but I couldn't afford $10 an hour when I was a kid. My mother couldn't afford $10 an hour. So like, really, I mean it. This is for free. This is for you. If you want to go into the description, it really truly is free. If you want problems, like a shortened list of topics that you could cover. Okay, number 7. The function h of x is used to calculate the average height in inches of a tomato plant X weeks after it's transplanted. These data are represented in the table below. Again, I do look real quick: 2, 4, 6, 9, 12, 16, and H 6, 12, 24, 51, 60, 64. Then it says between weeks 4 and week 12, the average rate of change in inches per week is 6, 8, 48, or 58. The average rate of change, that means often we write it as delta y over delta x. In this case, it really, since there's an h of x, this is delta h over change in height over delta x. So which means change in height divided by the change in x. So x goes from 4 to 12, and the change there is the difference. So 12 minus 4 is equal to 8. There's an ant on somewhere on my camera. Okay, I couldn't find it. Let's move on. Okay, so that's the change in x. So, and then I see that the change in h is from 12 to 60. So here, since the change is from 12 to 60, I already see that 58 can't be the right answer. And not only that, 48, because I'm going to end up dividing by 8. 48 can't be the right answer. So even if I don't know how to do the arithmetic, I know that the average rate of change has to be not 48 and not 58, because that the change per week is way less than that. But the actual change is 60 minus 12, which is equal to 48. And that's why a lot of students do stop and there and choose choice 3. But again, the average rate of change is change in h over change in x, or change in y over change in x, or delta y over delta x, or delta h over delta x, whatever. 48 divided by 8, according to my calculator, is 6. Okay? That's groovy. And so far, every single problem has been able to be turned into a passing problem, which is great. We eliminated choice 3 and choice 4. That made this a passing problem. Problem 8, Chloe is solving the equation x squared plus 5x equals 3x plus 3. Her first step is shown below. Given x squared plus 5x equals 3x plus 3. And then step 1, x squared plus 2x minus 3 equals 0. Which property justifies this step? The zero product property, or the commutative property, or the distributive property, or the subtraction property of equality? And it's important for us to know what these are. But also, if you are doing this problem, and they will ask they will ask this question. We know they will, because they used to ask this question before they changed the standards, like a year and a half ago. Then they asked this question after they changed the standards. So do assume that they're going to continue asking this question. So if you don't know what the answer is, what I recommend to you is actually explore how they got from the given to the step 1. And it looks to me like if they just subtract 3x, and also subtract 3, you do get to x squared minus 5, 2x plus, I'm sorry, to x squared plus 2x minus 3 equals 0. So what did she use? Is it the zero product property, or the commutative property, or the distributive property, or the subtraction property of equality? It's definitely not the zero product property. We did not do any multiplication to get from the given to the step 1. Now, is it the distributive property? The distributive property requires both addition and multiplication. That says that A times, for example, B plus C, that we could distribute the A. We just used it in a previous example. Distribute the A, and we get A times B, plus multiply the C by the A2, and we get A times C. That's what the distributive property says. So that we never did anything like that. So that's not it. And again, I didn't say what the zero product property is, but what the zero product property says, well, 0 times A equals 0, and also A times 0 equals 0. So you can multiply by 0 on both sides, and you just get 0. But also, if AB equals 0, like A times B equals 0, then it's guaranteed that one of the numbers is equal to 0. A equals 0 or B equals 0. We use that to solve equations by factoring all the time. And that was a not a ant. That was a tiny little, you know, one of those little spiders that you get in houses making a web on my camera. So okay. So we've by the way, we've eliminated two choices, so now we have a passing problem. Number 8, another passing problem. But now, is it the commutative property or the subtraction property of equality? The subtraction property of equality says that in an equation, we can subtract the same number from both sides of the equal sign. And so what we did, we actually used the subtraction property twice. We subtracted 3x from both sides of the equal sign, and we also subtracted 3 from both sides of the equal sign. So that is the subtraction property of equality. The commutative property says, by the way, that the order of addition only can change. At least that's the commutative property of addition. If you're adding two numbers, you could change the order of the numbers being added. I actually should reword this. The order of numbers being added can change. Oops. Can be switched. Can be switched. Can be switched, ed. It's not letting me write the ed. There we go. So it's not that. We didn't change the order of numbers being added. We actually subtracted from both sides of the equal sign, so that leaves us that. But this did end up being a passing problem by eliminating choice 1 and choice 3, which is great. Let's move on to number 9. Which function represents the graph of w of x equals absolute x shifted 2 units to the right? And is it g of x equals absolute x plus 2? Or h of x equals absolute x minus 2, or q of x equals absolute x, close absolute, minus plus 2, or r of x equals absolute x, close absolute, minus 2. It's important. I want you to know this. F of x transformed into f of x minus h, close parentheses, plus k. What this does, this shifts, this plus k does exactly what you suspect it does. It shifts the graph up k units. Okay? So f of x plus 3 or f of x minus h plus 3 shifts the graph up 3 units. As f of x minus h, let's say minus 7, shifts the graph down 7 units. It does exactly what you expect it to in the y direction. In the x direction, it can feel a little weird, but it is the opposite. So if you're subtracting h, in this case, this shifts the graph. So you're subtracting, so you might think it goes in the negative direction, but it actually shifts it in the positive direction. So this shifts the graph h units to the right. In the positive direction. So it does the opposite numerically, transformatively, as the same operation outside. So I'm going to use the same number outside. F of x to f of x quantity, close parentheses, plus 5. That shifts the graph up 5. But if you do f of parentheses x plus 5, that shifts the graph to the negative direction. To the negative direction, 5 units. So, yeah, so what we have to shift to the right, we have to subtract 2 from x. Now, just to make this a passing problem, by the way, we are shifting in the x direction. I'm going to cross out 3 and 4 because these shift in the y direction. Ugh. N. There we go. These shift in the y direction. Okay. So we just made it a passing problem after the fact, but here we have to shift it to the right 2 units. We have to subtract 2 units from x, and that leaves choice 2 and not choice 1. Now, not choice 1. But I want to say, can we do this problem on the calculator? You absolutely can do this problem on the calculator. Like if you just pull out the calculator, and to make the calculator big, it's just going to always block a little bit of the problem, so we just got to deal with that. If we press y equals and we do math, the absolute, let's see, it's the very first thing, absolute. So math and number, same place we found the n over d. The last option was n over d. The first option is absolute x. And then we're going to graph the choice that we suspected it is, choice 2, absolute x minus 2. Y equals math, number, then absolute, x minus 2. This better be the graph shifted 2 units to the right. The first one's going to be the blue graph. Let's calculator speed. Let's go to 200. This is the absolute value function. And there is the absolute value function shifted 2 units to the right. Exactly like we suspected. So the calculator confirms that we are right, and choice 2 is the answer. Let's go to number 10. Given the system of equations, y plus 4x equals 5 and 2x minus 3y equals 10, a step in solving the system of equations by using the substitution method would be 2 parentheses 5x minus 4 plus 4x equals 5, or 2 parentheses 5x plus 4 plus 4x equals 5, or 2x minus 3 parentheses 5x minus 4 equals 10, or 2x minus 3 parentheses 5 plus 4x equals 10. So this one I think is one of the slightly harder ones, maybe, but because we have to explore what is being substituted into. That said, I suspect strongly that choice 1 and choice 2 are incorrect as a fake student here, because I'm looking at the problem and I'm like, where did this 3 go? The 3 seems to just be completely gone, and doesn't seem to be, in the substitution process, there seems to be no algebraic equation or algebraic operation that's going to end up eliminating the 3. Like if I divide by the 3, then you're going to end up having 3's in the denominator. There's no multiples of 3 to cancel the 3. And if you don't divide by 3 and you just leave it there, then the 3 just stays around. So I suspect, fake student me suspects that these are incorrect. And if I go by that, I mean, technically I don't have a passing problem, because fake student me is saying I think that these are wrong because they're missing the 3 completely. But fake student me is correct for exactly the reason that I explained. Now, a real student me, or fake student me, might also go beyond what I just said and say, oh, if I substitute into the first equation, I get something plus 4x equals 5. So they're substituting, these are both substituting for x using the second, but if you're substituting for x in the first equation, you have to do that using the second equation. And if you try to do that using the second equation, you don't get 5 plus 4x from the second equation. In fact, now I'm realizing, I mean, fake student me, I already knew this, but fake student me is realizing not only did they not do anything correct with the second equation, they didn't use the second equation at all. So this one is actually just incorrect because it didn't even bother using the second equation in any way. So that said, if I look at the second at choice 3 and choice 4, now I see that they're actually substituting into the second equation, and you got 2x minus 3, something replacing y equals 10. So they're definitely substituting into the second equation, and it looks like they're using the numbers from the first equation. Since I'm substituting y, I have to solve for y. Y plus 4x equals 5. I'm going to subtract 4x, subtract 4x. I get that y equals 5 minus 4x. So that's going to go into the problem, and this one has a 5 minus 4x. This one has a 5 plus 4x, wrong operation. So we eliminate that, and choice 3 is the only remaining correct answer. So, and in fact, if we do substitute that, we do get 2x minus 3. Replace the y with that 5 minus 4x. That's equal to 10. Yeah, choice 3. There are other ways that you could do this problem using the calculator. For example, what you could do is you could actually graph them and solve that way. So you get an x and a y, and then you could plug in the known values of x or y. Actually, in this case, the known values of x only, because all 4 choices have x's only, and see which equations give you the correct value of x. I can't guarantee that it's going to be all of them. I can guarantee that it's not. I'm sorry, I can't guarantee that it's only going to be choice 3, but I can guarantee that it's not only choice 3. I'm sorry. I can't guarantee that it's going to be only choice 3, that it's going to eliminate all 3 other choices. But what I can guarantee is that at least one of the choices in that case is going to be eliminated. That's what I was trying to say. Number 11, which equation is equivalent to x squared minus 6x equals 27? Is it x minus 3 squared equals 27 minus 9? Or x minus 3 squared equals 27 plus 9? Or x minus 3 squared equals 27 plus 36? Or x minus 3 squared equals 27 minus 36? This is doable by graphing. And I said that for every single problem, I would show you a way to do the problem by eliminating some choices. And this one can just be done by graphing. Let's see. How do you do it by graphing? Or by even by table? Let's see. Let's do it by graphing. Let's clear this and clear this. Let's do x squared minus 6x. And let's graph the function y equals 27. Okay? And if you graph these, you'll notice that they don't graph. Here's the x squared minus 6x, but then the line y equals 27 doesn't fit on the screen. So if I do zoom fit, where's zoom fit? Leave it 0. Zoom fit, that's going to make everything fit. So here's the parabola, and here's the quadratic, and I see that they intersect at x equals like around -2, or -3-ish. Let's see, 9 plus 18, actually exactly at -3. 9 plus 18 is 27, and then also at, I believe, 9. No. Let's actually look at the table. Why am I struggling with this? 9. Yeah, like I said, 9. And 9 squared is 81. Yeah, I don't know why. 9 squared is 81 minus 54 is 27. That said, that means that I know the answers. The answers are -9 and, I'm sorry, +9 and -3. So whichever of these answers, if I go do the same thing and I do x squared, so parentheses, x minus 3, I'm going to test choice 1 just to arbitrarily always choose choice 1 for the test unless choice 1 is not available. X minus 3, close parentheses, squared. And then the fourth function is going to be 27 minus 9. If these two don't agree at x equals -3 and x equals 9, then they're wrong. And if I look at y3 and y4, so these agree on x equals -3, y1 and y2 agree, as we suspected. y3 and y4 do not agree, so that eliminates choice 1. What I just did for us is, this doesn't seem to be a passing problem. Granted, except that it absolutely is, because all the other choices have x minus 3 squared, and you could do the same exact thing with the 27 plus 9 and the 27 plus 36 and the 27 minus 36. So you could just do this problem doing what I just did without doing any theory. I can't do it that way because I have to show you how to do this if this was a part 2 question. And they do ask this question on part 2, 3, and 4. So that said, though, I have a method for you that will work for you on the calculator. So if you do appreciate that, thank you guys. Comment about how helpful this video is. I thrive on knowing that I've been able to help you pass the Regents. So that said, how is it that this problem was done? This is the first step in completing the square. Okay, so that's actually what they're doing. Complete the square. So we're gonna do that. Complete the square. All right, so I'm going to write x squared minus 6x. I'm going to leave a gap equals 27. And then I'm going to note that we do need this in this method that a equals 1. So what we're going to write is b equals negative 6. b over 2 equals negative 3. Negative 6 divided by 2 is negative 3. And now also b over 2 squared is the square of b over 2, which is equal to 9. And so we're going to add that to both sides of the equal sign. And the reason we do that, that is not an arrow, that is a 9. Thank you. The reason we do that is that we've converted the left side into a perfect square. So we've used the 9 here and here and here. And now we're going to use that negative 3. And how do we use that negative 3? The way we use the negative 3 is that the left side is equal to parentheses x minus that 3, close parentheses squared, and that's equal to that 27 plus 9. And where did we use that negative 3? Again, we used it right here. That's where we use the negative 3. Okay? So which answer matches exactly this? The answer that matches exactly this is choice 2. And not for nothing, 11 passing problems in a row. Number 12, the box plots below summarize the ages of athletes on the swim team and the track team. And I look at the box plots real quick. I see this one has a median at 13, this one at 12. Based on the box plots, which statements must be true? Is it that the IQR for both teams is the same, or there are more athletes on the swim team than on the track team, or the median age of the swim team is less than the median age of the track team, or the range of ages of the swim team is smaller than the range of ages of the track team? Okay, so definitely recommend trying to eliminate any answers that you can, as usual. And by the way, I do recommend trying to pick an answer before you hear what I say. That's actually the best way to learn from this video. But that said, in terms of test taking strategy, none of these plots actually show a number of people who were counted. So the question, there are more athletes on the swim team than the track team, that one has to necessarily be incorrect. Because again, the box plots don't show quantity. Don't show quantity. That's okay. Don't show quantity. So this is the first one that at least that we've eliminated just one answer. Now let's look at the medians to see if we could just quickly eliminate choice 3 and see if this is we can turn this into a passing problem. In fact, the only way to do this question is to do the calculations. So if you have a certain amount of intuition on the problem, you might be able to do the problem as well. So this median is 13, right? And by the way, let's actually label these as Q0, Q1, Q2, Q3, and Q4. Same thing, Q0, Q1, Q2, Q3, and Q4. And notice that the some of these already have other names. So the Q2 is also known as the median. Q0 is called the min or minimum. Q4 is called the max or maximum. And then Q1 is called either quartile 1 or the lower quartile. And then Q3 is called, quartile 3 or the upper quartile or the third quartile. Okay, and the same thing for these numbers. So the median age of the swim team, 13, is less than the median age of the track team, which is 12. This is very false. So that's not it. So now, what about choice 1? The IQR of both teams is the same. You do need to know what the IQR, and actually with that note, let's actually, instead of reminding ourselves of the formula, this is a good chance for us to go to the back of the test and look to see what the test has in the formula sheet. And we see that in the formula sheet, there actually is a formula for the interquartile range. IQR is equal to Q3 minus Q1, the third quartile minus the first quartile. So let's go back to the test and let's write this down, that IQR is equal to Q3 minus Q1. And by the way, it says the ranges of this for choice 4, the range of ages of the swim team is smaller than the range of ages of the track team. This one you do also need to know that the range is equal to max minus min, also known as Q4 minus Q0. And so the IQR of both teams is the same. So IQR for the swim team is equal to 16 minus 12, which is equal to 4. And the IQR for the track team is equal to 14 minus 10, which is equal to 4. It looks like these are the same. And the ranges do not seem to be the same. 9 to 17 versus 8 to 15 for the swim. This is just checking. 17 minus 9 is equal to 8. And for the track, 15 minus 8 is equal to 7. Not equal. Okay? So these are both equal for choice 1, not choice 4. Let's continue to number 13. So the graph of f of x is shown below. And I see there's an open circle here, from 10 to 50, 5 to 12, and this one climbs steadily before becoming flat, before jumping, and then closed circle up there. The domain of this function is closed 0 to 12, or closed 15 to 45, or open 0 less than x less than 12, or 15 less than x less than 45. Just some quick notation. Let's say bracket A comma B bracket represents like A is less than or equal to X, and that's less than or equal to B, versus if you have parenthesis A comma B parenthesis, this means that A is less than X and less than B. And can you mix and match these symbols? Absolutely. That's actually part of the condition. So for example, you could have parenthesis A. Why is this not writing? Parenthesis A, comma B, closed bracket. This means that A is less than X is less than or equal to B. And similarly, you could have the bracket on the A and the parenthesis on the B, which means that would mean A is less than or equal to X and less than B. So that said, we also need to know what the domain of a function means. we do need to know yeah, we do need to know what the domain of the function is. However, if you just can't remember the difference between no domain and range, this we do recognize that this is an open circle, and therefore it's not really part of the function. It's not included. It's a boundary point and it's not part of the function, which actually eliminates all the ones that have a closed circle at the beginning. So it's not 0 to 12 inclusive of 0, and it's not 15 to 45 inclusive of 15 on the way up. So that means we've turned this problem into a passing problem, just like we turned the previous problem into a passing problem. 13 out of 13 problems so far turned into passing problems. Now, we do need to know, this is now how to do the problem. We do need to know that the domain is equal to the set of x coordinates that are mapped to y coordinates. To coordinates, C-O-O-R-D-S, coordinates. Okay? So which x coordinates are mapped to y coordinates? Well, and by the way, the range is equal to the set of y coordinates that are mapped to by x coordinates. And it happens to be x, y, alphabetical order, domain, range, dr, alphabetical order. So if you're trying to remember which one pairs with which, the x goes before y and d comes before r. So x is paired with domain and y is paired with range. It's a nice little mnemonic. So now, which x coordinates are mapped to a y coordinate? Not 0, because there's an open circle at 0, but if you continue to the right, there's a closed circle at 12. So at 12, those are included. So the domain is equal to the set parenthesis 0, comma 12 bracket. Not including 0, yes, including 12. And the one that has that is choice 3. Students who got it wrong by guessing choice 4 are students who guessed the range. The range, in fact, is 15 less than y less than or equal to 45. Number 14, the sum of 3 and radical 5 is rational since the sum can be expressed as an integer, or rational since the sum can be expressed as a non-terminating decimal, or irrational since the sum can be expressed as a terminating decimal, or irrational since the sum cannot be expressed as a terminating or repeating decimal. And that's great. So that means you need to know what a rational number is. And if you happen to know what a rational number is, you can get really far with this problem. So rational number has two completely equivalent solutions, okay? Completely equivalent solutions. One is it can be written as a fraction. Notice I didn't say is, can be written as a fraction. An equivalent solution is it can be written as a terminating or repeating pattern decimal. Okay, terminating or repeating pattern decimal. And so let's just be clear here. A terminating decimal is a decimal that just ends. Okay, so that's not unclear. But what about a repeating pattern decimal? The reason we were clear about what kind of pattern it is that there are plenty of decimals that have a pattern, but they're non-repeating. Maybe there's a rule that like extends a certain piece of like the length of a certain pattern longer and longer and longer, like 0.1, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, etc. So I'm adding more zeros before putting a 1. That's not a repeating pattern, but there is a pattern there. But that number that I just mentioned is irrational. This number, 3 plus radical 5, is irrational. So why is it irrational? Because 3 is rational. It's an integer. Notice that it can be written as a fraction, 3 over 1. So it's rational. Also can be written as a terminating or repeating pattern decimal, 3.0. There you go. But radical 5 is not rational. In fact, the radical of any number that's not a perfect square is irrational. So it turns out that a rational number plus an irrational number is equal to an irrational number. And this can actually be proved by contradiction. So suppose that the sum of a rational number and an irrational number was equal to a rational number. Then what you could do is subtract the rational number from both sides of the equal sign. Then you have an irrational number somehow equal to a supposedly rational number minus another rational number. But if you have two fractions, you can do like crisscross bottom or something like that, or common denominators to add the two fractions, and then you get a fraction. So that would imply that an irrational number is equal to a rational number. That can't be, because you can't have a number both be able to be written as a fraction and also not be able to be written as a fraction. So that's the proof that a rational number plus an irrational number is irrational. So this is definitely irrational, and that turns this into a passing problem because we cross out the choices that say rational. But now what about these? Irrational, since the sum can be expressed as a terminating decimal. A terminating decimal would imply that this is rational. So we're saying like it's irrational because it's not irrational. It's irrational because it's rational. That doesn't make sense. So that doesn't make sense. So that's not the answer. And this one's, it's irrational since the sum cannot be expressed as a terminating or repeating pattern decimal. I like that. Number 15, which expression is equivalent to a to the 8th minus b to the 6th? I need to move this word up a little bit. There we go. Which expression is equivalent to a to the 8th minus b to the 6th? Is it a to the 4th minus b cubed squared, or a to the 6th minus b to the 4th squared, or a to the 4th squared minus b to the 3rd squared, or b to the 6th squared minus b to the 4th squared? This one is asking us, do we know some of the basic algebraic rules for arithmetic? However, there's another way to do this problem, one that I didn't mention in other problems because we had other methods of doing them. One method of doing this problem is taking test values. So this is process of elimination. Okay. Take test values. And I separate test values into easy versus rare. Easy include 0. Often the number 1 is easy to plug in. Sometimes -1 is easy to plug in, but also like special numbers for the problem, roots, tend to be easy to plug in because you'll just get a bunch of 0 very easily. But also rare. In other words, rare are numbers that you can't plug in easily unless you're using a calculator necessarily, but it's rarely not going to detect what the right answer is. So numbers like 9, 11, pi, even a decimal like 1.5. 1 point, I'm not going to do 1.5. I'm going to do, because that's a little less rare. How about 1.3? Um, things like that. Um, so those kinds of numbers. So like, for example, if I wanted to do the problem 15 by plugging in test values, I would plug in x, no, not x, a equals 8 and b equals 6. Do I like that? Yeah, I like that. And this will give me the answer with nearly 100% certainty. So will give answer with, actually in this case, not even nearly 100% certainty, with 100% certainty. All the numbers, all the choices will be wrong except for the one answer that is right. So I have turned this into a passing problem just via plugging in numbers. I didn't state which answers get eliminated, but because I'm not gonna plug those in for you for every single choice, but I will plug in into the original. So you see what I'm saying? 8 to the power of 8. I almost don't like the numbers that I chose. Only because I'm like, I chose the base and the exponent to be the same, and I don't want to cause a confusion. I'm going to change my numbers to 9 and 7. And 9 and 7, actually 7 is a super rare number. So let me change those numbers. Let's see, 9 to the power of 8 plus 6 to the, no, not 6, 7 to the power of 6. And I get this number, right? Now I'm going to plug into choice 1, parenthesis, 9 to the power of 4 minus 7 to the power of 3, that quantity squared. Enter, and I get different numbers. So choice 1 is not the correct answer. And in fact, if you plug into the other ones, this choice of numbers will guarantee you that you are not going to select the correct answer, okay? Or the incorrect answer with these test values, which is great. So this is, in fact, a passing problem, despite the fact that I didn't personally eliminate it for you, because you can now do the work and eliminate it yourself. So now, how do we do this problem? There's some details to know. I'm going to say P plus Q, or P minus Q. I'm sorry, P squared minus Q squared is equal to P plus Q times P minus Q. That's an important one to know, especially since this one is kind of testing that. It's important to know that P squared minus Q squared is not equal to the thing that every student gets wrong, P minus Q squared. I try not to even write down the incorrect thing because then students remember the wrong thing. P squared minus Q squared is equal to P plus Q times P minus Q. Nothing else. So if you plug in an a to the 8th, an a to the 8th is an a to the 4th squared. And a b to the 6th is a b to the 3rd squared. So if they had given a to the 8th minus b to the 6th is equal to a to the 4th minus b to the 3rd times a to the 4th plus b to the 3rd, if that were one of the choices, that would give us the correct answer. But it's not one of the choices, and in fact, that confirms that this is just an incorrect factorization. This one is pulling out a 2 under addition from the 2 exponents. That's just not how algebra works. Another detail that you need to know for algebra, I would love to teach you every exponent rule, but I have a lot of videos out, don't I? So I do with all of those videos. You do need to know that p to the power of m, that to the power of n, is equal to p to the m times n. So that, in that case, if you have power to another power, you can keep the base and multiply the exponents, which means that a to the 8th is equal to a to the 4th squared, because 4 times 2 is 8, which means that this problem, which has an a to the 4th squared, is correct. This one that has an a to the 6th squared, this is equal to a to the 12th, and just like this is equal to b to the 4 times 2 is 8. That's not the numbers that appeared in the original, so 4 is not correct, leaving us with choice 3. Let's go to number 16. I'm running out of space here, aren't I? The sum of 2 radical 27 and 4 radical 12 is 14 radical 3, 34 radical 3, 6 radical 39, or 8 radical 39. We did a problem almost exactly like this one earlier in this video, number 1. We just plugged it into the calculator and we were able to confirm which answer did or did not make sense. Since this one is asking which one is equivalent to the sum of 2 radical 27 and 4 radical 12, we know that there can only be one. So therefore, all 4 choices must be either the exact same number as the sum or just something totally different. I'm not going to plug it into the calculator because you know where the radical button is. The radical button is behind the square button. So if you wanted to do 2 radical 27, the radical is in blue behind the square button. And so press the blue second button and radical 27. Enter. That's how you enter radicals into the calculator. Okay? Minimize that now. And so I'm immediately gonna hop over to so this is a passing problem without even using trickery to eliminate the choices, because you could literally just plug the numbers into the calculator and that turns it into a passing problem. There is a way to turn it into a passing problem though, if you just happen to know some basic rules of radicals. When you're adding, this is a plus, the sum, so you're adding, the radicands, the 27 and the 12, they don't add together. So you're not going to get 27 plus 12. That's illegal. Adding radicands from separate radicals is never legal. So that means that the ones that have a radical 39 are instantly wrong. Instantly wrong. Choice 3 and choice 4 just are not correct. So that said, we need to know how to do this one as if it were a part 2, besides just being able to plug it into the calculator. And the way we do it is by simplifying the radical. So radical 27 can factor as, now we're not looking just for any factors of 27, we're looking for perfect square factors of 27. Radical 9 and radical 3, and that's equal to 3, and this is just plain old radical 3. So 2 radical 27 is equal to 2 times 3 radical 3. Okay, we do the same tree for radical 12. Radical 12 factors as the greatest perfect square factor of 12 is 4. So we could do radical 4 times radical 3. And radical 4 simplifies as 2. And the radical 3 just is radical 3. And so 4 radical 12 is equal to 4 times 2 radical 3. Which actually we should simplify this as 8 radical 3. And the 2 times 3 radical 3, we should simplify it as 6 radical 3. And so if we're looking for the sum of these two numbers, so that means that the sum, 2 rad 27, plus 4 rad 12 is equal to, this number, instead of 2 rad 27, we're going to write 6 rad 3. And instead of 4 radical 12, we're going to write 8 rad 3. And these have the same coefficient, or the same factor, radical 3, the same factor pair. So by the distributive property, we can combine the 6 and the 8, rad 3. So this is equal to 14 rad 3, which is exactly what the calculator would have told us. But of course, we need to know how to do it for part 3s. and 2s and 4s. And you'll see that they do ask us to simplify radicals. And with that note, problem 15, which is actually one problem ago, secured us a passing grade. So we have officially, with 20 problems to go, actually technically 19 problems to go, we've already passed the test. That's the benefit in showing as much work as possible. So congratulations on passing the test. We have secured a passing grade. With that, we are going to jump on to number 17. And I just want to tell you, like, I know I have full confidence in your ability to do well on this test. All you got to do is put in the work. I do recommend trying the problems before you hear what I say, because you'll learn more from it if you hear what I say. In fact, what I recommend to you, if this is like you're a few hours before the Regents even, it actually is more worth your time to try the problem than and then listen to how I do it and make sure you're right, than it is to just listen to me do it and hope that it osmosis into you. But you do you. That's my recommendation. Number 17, the sum of Tim's age and Jack's age is 44. Tim's age is 4 less than 7 times Jack's age, x. An equation that could be used to model this scenario is 7x minus 4 plus x is 44, or 4 minus 7x plus x is 44, or 7x minus 4 is 44, or 4 minus 7x is 44. One of these is I feel very strongly as a fake when I talk about fake student me, I just mean like I'm simulating myself as if I were a student, as opposed to, or especially a struggling student, as opposed to me being the teacher and the tutor who's been doing this for 26 years. Fake student me says no matter what Jack's age is, it's 7 times that number is going to be a bigger number than 4. So 4 minus that number is a negative number. You got a negative number equal to 44, which is a positive number. That doesn't make sense. So that eliminates that. This actually makes me feel like choice 2 might actually be wrong, because fake student me is thinking that this should be a big negative number plus or possibly a big negative number, plus another number, e being 44. So I suspect that this one's wrong. So this is the first one that I am not doing by process of and turning it into a passing problem, because I really think that at this point it might be better to reflect on where this equation actually comes from. Now, are there ways to eliminate other choices? Yes, there are. Finding out, guessing and checking what you think the age might be. The fact is that since Tim's age is 4 less than 7 times Jack's age, 7 times Jack's age, and we know that the Regents doesn't actually try to create unrealistic problems like Tim being 437 years old or something insane, or like someone's age being a negative number. That doesn't make sense at all. They do take realistic ages. And since we have to multiply an age by 7, Jack's age is probably a fairly small number. You might actually be able to guess at which numbers work, especially since the sum of their ages is 44. Neither one of them is very old. You could actually literally guess and check. Guess and check to get the answer. That said, the way I think about this one, I think of this as Tim's age plus Jack's age is equal to 44. And that's what I start with. Notice that I wrote this in words. I just want to be clear. I actually recommend writing these words. I don't, like, when you're doing part 2s, you're going to find that that there's some problems where they ask us for an equation. It might, when I do it, I'm going to write it in words. I'm going to write equations in words, or inequalities in words, whatever the problem calls for. And then I convert the words into numbers or variables. Now, I know that Jack's age is X. And then Tim's age, this is the one that we got to get. 4 less than. 4 less than. This means that whatever I have to subtract 4 from it to get 4 less than that. Okay? Then what is it 4 less than? 7 times Jack's age, so x. So this is 7 times x. That means that Tim's age is, so in here goes 7x. So 7x minus 4, close parentheses, plus Jack's age, x, is equal to 44. And that exact equation appears as choice 1. So we got that one 100% correct. And we wrote a word equation first. Highly recommended. Number 18. Given the function g of x equals 2 to the power of x plus 3, all that over x squared minus 2, what is the value of g of negative 2? Is it 1, 1/3, negative 1, or negative 1/3? Fun fact, can easily be done on the calculator. And this is another problem where I'm going to review with you the ability of your calculator to plug in a fractional expression. So I'm going to press y equals, oops, calculator's off, press y equals, I'm going to clear and clear and clear and clear. Most videos when I do this, I don't clear anything, and I'm almost regretting clearing that. So I'm going to speak on it. I actually prefer, you have 10 lines to make y equals. I actually prefer to, I'll show you, like, if this equation is, so this is a test taking strategy. If this equation is 3x or something like that, and you need it to not graph, go to the equal sign and press enter. That unhighlights the equal sign. That means that unhighlights the function. It's not going to graph y3. So that's so that you'll see. I'm going to do that now by plugging into y4 and I guess 1 and y2. So y1, it's a horizontal fraction bar. So I'm going to go to the horizontal fraction bar, math, to the right for number. The last option is n over d, enter. The numerator is going to be 2 to the power of x plus 3. X plus 3. The denominator is x squared minus 2. And they want to know what g of negative 2 is. Go to the table, look for negative 2. G of negative 2 is equal to 1. That's easy. So the calculator tells us the answer. So could I have done this in any other way? Could I have eliminated any choices? If I plug in negative 2, it does help to know that a negative number squared is equal to a positive number. If you happen to know that a negative number squared is equal to a positive number, then you can actually just say the numerator, the denominator is going to be positive. Negative 2 squared is a positive 4, minus 2 stays positive. And then if you know that a positive number to any power at all, any real power at all, is a positive number, the numerator and denominator are both positive, so the answer is positive. That eliminates these two choices because the answer is greater than 0. It's positive. Now, how do we do this on paper? Because it could be a part 2. G of negative 2 is equal to 2 to the power of negative 2 plus 3 over negative 2, I need parentheses, close parentheses, squared minus 2. Despite the fact that we use a horizontal fraction bar in the calculator, we still need parentheses around the negative 2. And if you don't put parentheses around the negative 2, that's where the answer negative 3 came from. So negative 1/3. If you didn't put a parentheses around the negative 2 in the denominator, you got negative 1/3. And you're like wondering maybe, wait, you said 1. Why am I wrong? And it's because you didn't put parentheses around the negative 2. So simplify this. 2 to the power of negative 2 plus 3 is 1. Divided by negative 2 squared is 4 minus 2. 2 to the power of 1 is equal to 2. 4 minus 2 is equal to 2. 2 divided by 2 is equal to 1, exactly like we suspected, and that would give us full credit on a part 2 question as well. So we are geniuses. Number 19, 4 graphs are shown below. We got an upside down parabola, a vertical line. For C, for B, we have a horizontal line. For D, we have a circle graph. Which graph represents a function? A only, A and B only, A, B, and C only, or A, B, C, and D. And this one can definitely be done by process of elimination. If you happen to remember, a function passes the vertical line test. Function passes the vertical line test. And what is the vertical line test? And it's a really easy test to perform. And that's the only condition, by the way, that a function has to satisfy. It just has to satisfy the vertical line test. If the relation satisfies the vertical line test, it's a function. If a relation does not pass the vertical line test, it's not a function. So it's an if and only if statement to do the vertical line test. What is the vertical line test? If any vertical line crosses the graph twice, the relation, twice or more, the relation is not a function. So that's the vertical line test in the negative sense. Let's go for the vertical line test in the positive sense. I wanted green there. If every vertical line crosses the graph at most, I'll put the word at here, that crosses the graph at most once, every vertical line, which means you do have to imagine literally every single possible vertical line. But in practice, that's not that difficult. Every vertical line crosses the graph at most once, then the relation is a function. Looking at the red, if any vertical line crosses the graph twice, the relation is not a function. So if I'm looking at these graphs, I immediately see, like I could graph, and I'm going to graph it in red, a red vertical line here. And there it is, crosses twice, boom. So this relation is not a function. So any that have D, which is only choice 4, is eliminated. Now, what about choice C? Well, choice C is literally a vertical line. I'm gonna highlight that one so that you could actually see that I drew it. Okay, that is a vertical line. Okay, a vertical line. It fails the vertical line test because that vertical line crosses that vertical line infinitely many times. So this vertical function, this function is not this relation is not a function. And if you need 2 points, here's one, here's another, here's a third, here's a fourth. It crosses that infinitely many times. So any that have C in it is wrong. We now have a passing problem, which is phenomenal. We only gave up the making it a passing problem, I think, on one problem, although guessing and checking would have helped. So I did give you a second strategy. But what about A and B? Same deal as before. Let's go for green lines now. Vertical line. That was, why did I not select green? Okay, vertical line. Okay, vertical line. Every vertical line crosses exactly once across that horizontal line. So this is a function. And by the magic of multiple choice tests, that does directly imply that choice 2 has to be the answer. But so A is going to be a function, but in fact, let's just test it. Vertical line, vertical line, vertical line, vertical line, vertical line, function is a function. So A and B only. I hope that I wanted to go through that one really thoroughly. And if you do appreciate that, please let me know. Because there's despite the fact that a lot of students know the vertical line test, and it's such an easy test to run, students get this question wrong. They forget to actually perform the vertical line test to get that question right. Now, let's actually take a very quick snack break. Now, how do you take a snack break if you're watching this video? If you're watching in school and the teacher just wants you to fast forward, just fast forward. If you got lunch in a few, and you don't need to listen to me talk about snacks. However, it does help. I do have recommendations. And why do I add a snack break to every single video? Literally so that you can have a snack break or a potty break. If you're listening to this at home, just take me with you while you're getting your snacks and doing whatever it is you need to do. Stretch so that you could come back and watch. A snack that I recommend during the Regents, like a Fairlife milk, because it is lactose free, has a lot of protein, so it fills you up, a little bit of fat and a little bit of carbs to give you a little bit of energy. Not that much carb and fat, so it doesn't give you that much energy. But because it's a small amount of liquid, it doesn't make you have to go to the bathroom. And because it's mostly protein, it doesn't also make you have to go to the bathroom. I do recommend, I don't have the pure protein bar here, but I do recommend pure protein bars. You're not eating them for the health of it. You know, for this test, you're eating them for the staving off hunger and giving you a little bit of energy. They have a little bit more fat and a little bit more carbs, so it gives you a little bit more energy. And they have a lot of protein, but it's a small bar, so it doesn't sit in your belly and make you real full and annoyed while you're in the middle of a test. And also isn't so flaky that it leaves chocolate bits everywhere. Um, Whatever flavor you prefer is fine. Or any other protein bar, to be honest. Really any other protein bar, just check for milk. Because although Fairlife milk is a lactose-free product, not every product that has milk in it is lactose free. And that's important because even people who are not lactose intolerant, uh, lactose intolerance is a relative thing. You might be just barely lactose intolerant, and meaning that like the smallest amount of lactose makes it to your belly, um, to your gut. At which point it makes you kind of want to go to the bathroom. So I recommend getting things that are lactose free for the Regent's time. I like this again. Small amount of liquid hydrates you enough while also not making you have to go to the bathroom. Um, Now about coffee, and I've mentioned this in every video, you should treat coffee as the drug that it is. It is a legal drug, so I'm not going to rant against coffee, especially as a Dominican. It's practically, drinking coffee is practically our pastime. But the thing is, though, it's a stimulant. You might find if you don't drink coffee with frequency at all, you might find that the coffee does the worst thing possible for you. It makes you so hungry, like a whole body hunger that you've never felt before. Um, and a lot of people who drink coffee professionally, like adults, swear by coffee staving off hunger. That's not actually true. It's just that because we've gained a tolerance to it, the way it affects us is different. But always, eventually, even professional coffee drinkers get to the point where they're finally ready to eat, and it might actually be longer than normal. It might have actually staved off that starving feeling. But the moment we eat, we tend to eat things that are way more fatty and way more carby than we intend. It actually has that same effect, even on the people who feel like it doesn't have that same effect. So coffee does make you hungry. So if you are not a professional coffee drinker, I highly recommend, if you're gonna do coffee, decaf, decaf, and lactose free anything. So uh, if you're getting coffee at Starbucks or something, ask them to use lactate instead of regular milk. Whatever it is that you need to do. Our snack break is over. We are going to jump right into number 20. I hope that you're ready. If you aren't ready, feel free to pause. Feel free to finish getting your snacks. Do what you need to do. Use the restroom, but get ready to work. We are going on number 20. The formula to calculate kinetic energy is 1/2 mv squared, where k is kinetic energy, m is mass, and v is velocity. That is the true formula for kinetic energy in basic Newtonian mechanics. When m is written in terms of k and v, the equation is m equals 2k over v squared, or m equals 2kv squared, or m equals radical 2kv squared, or m equals k over 2v squared. Honestly, this problem is, I think, doable, even for students who struggle, because if it's a part 2 question, you might struggle a little bit more. But if it's not a part 2 question, which it's not, the multiple choices might actually assist you in getting the question right. For example, This one is k equals something involving a number, an m, and a v. And they're asking for m written in terms of k and v. In other words, m equals a number k and v and maybe other operations. We know that we have to solve for m. If we were doing the problem properly in a part 2 question, we would have to solve for m in terms of k and v and any other numbers. Now, can I say anything at all for process of elimination? Process of elimination? I'm not only going to give you a process of elimination that'll help. It's a process of elimination method that will get you full credit on this one. And it's the same plug-in test values. Test values. Now you can't choose k, m, and v because there's an equal sign. There's a relationship between k, m, and v. But you can choose two of the variables. Let's say m equals 9 and v equals 7. The same two numbers that I used in the previous one. Or if you want easy numbers, 1 and 2. But if you want difficult numbers or rarer numbers, 9 and 11, that'll tell you 9 and I'm going to actually purposely. Ooh, I don't know why that erased. I wasn't touching my writing pad. I'm going to choose m equals 8 and v equals 7. The reason I did that is because then that makes k a nice integer. Just because. And when I multiply it by a half, I'm going to get an integer. Anyway, so m and k will then give us that v is equal to, I want to say 190. Oh, no, not v. K is equal to 196. 1/2 times 8 times 7 squared. That's 49 times 4. 4 times 49, which is equal to 196. And so now I could plug in those numbers into all of these choices, and whichever gives me the correct answer is very likely correct. But because I chose rare numbers, 8 and 7, it's practically guaranteed, more than 99% guaranteed, that every single incorrect answer is going to give me a different number than the correct answer will. Okay, I know that when I plug in k equals 196 and v equals 7, I gotta get 8 out of it for m. So, passing problem. This is 100%. This is 100% certainty. And the reason it's 100% certain, even though it's like more than 99% certain, is that suppose that there were two answers that gave you m equals 8. They're not, but suppose there were. Take different test values. Then that'll do it. So passing problem. But how do we do this one as if it were a part 2? So we have to solve for m. So we have k equals 1/2 mv squared. Okay. So this is the place where I recommend thinking about it this way. Suppose I don't know how to solve this literal equation. By the way, the topic of this is literal equations. Why are they called literal equations? Just because they're literally letters. Literal, right? When you're reading, that's literature. Literal equations because there's a lot of letters. That's literally the reason. So if I'm thinking about how to do the problem, a lot of students don't even take step 1. So step 1 is trying to do anything to solve for m. I need to solve for m. I see that m is being multiplied by a half and multiplied by v squared. So if I'm thinking about the problem, if there's any piece that I don't know how to eliminate, I could literally eliminate the other thing. I know that I can eliminate the half by multiplying by 2, and I get that 2k, that cancels out the 1/2. 2k is equal to mv squared. So any answer that doesn't have a 2k is wrong. I suddenly am able to eliminate a choice even if I don't really know how to do it. So I have here, again, 2k, I need more space, 2k equals mv squared. Now I'm saying to myself, wait, but I know that I'm multiplying by v squared, m by v squared. I can eliminate the multiplication by v squared by dividing by the same number, v squared. And I get that M is equal to 2k over v squared. And so the answer is choice 1. Before I go to number 21, so I've mentioned that I tutor, JuanTutors.com. If you notice that I get any question wrong on this video, so what you have to be the first person to point it out. Now, I'm not saying any mistake, because again, I'm not deleting any mistake, but I've got to go back and correct the mistake. If I don't correct the mistake and you find a mistake in this video, let me know. And if you're the first person to point it out, I will give you a free hour of tutoring. Now, when I say a mistake, I do mean a mathematical mistake. Don't mean that my handwriting's sloppy. I don't mean that my decimal creeped up a little bit. No, I mean an actual true mathematical mistake. I'm the judge of that. So, I'm the judge of that. Now, that said, am I being genuine here? There was a video on a chemistry video that I did. I had the right answer in my work, and I described the right answer in my words. But then, sometimes when you're reading a problem and you literally switch in your mind one word for another, like I did that in my mind halfway through. So in the first half, I had the words in my mind correctly. And then in the second half of the explanation, I had the words in my mind switched, and I ended up circling the wrong problem. And for some reason, I didn't go back at that exact moment and check my answer, which I do for every single question. Someone pointed it out, and I told them, if you contact me on JuanTutors.com, I will let me know. We'll confirm your YouTube account, and then I'll give you a free hour of tutoring. Number 21, the solution to the equation 2 parentheses 3x minus 1 close parentheses over 3 equals x plus 2 is 1/3, 2/3, 4/3, or 8/3. Yet another problem that can be done by plugging in the numbers into the calculator and seeing which one of these gives you the correct answer. And to answer a question, for this test, I'm always going to plug in the first choice into it. Can you put a fraction in that with using that horizontal fraction bar inside another fraction using the same horizontal fraction bar? And let's test it. 2 parentheses. We're going to test choice 1. 3 times 3 parentheses, let's say 1/3. So in fraction form, if you're comfortable just doing it without the fraction form, but go ahead. But I'm going to recommend doing it this way if you struggle at all with fractions, okay? Close parentheses, so you could put a fraction inside another fraction. And then the denominator is 3. Ooh, not a 2, it's a 3. Enter. And that's a 0. And that is, the question is that equal to 1/3 plus 2? Before I plug in 1/3 plus 2, 1/3 plus 2 is not 0. So the answer 1/3 is not the answer. Okay, so now, is this a passing problem? Yeah, because you could literally just plug in the numbers. And so you could eliminate all the incorrect answers. So that said, this can easily be a part 2 question. Okay, so, or part of a part 3 question. So I'm going to solve it using the methods that we would normally use in a part 3 question. I see that there's x's on both sides of the equal sign, so I can't do this purely by the inverse operation method, but I still use inverse operations to eliminate numbers to make the problem simpler as I go along. So for example, I see that this x on the left side is stuck inside a parentheses, being multiplied by 2, and then is on the numerator of a fraction bar. So I got to get rid of everything around that somehow, one way or another. So one way I'm going to do that is multiply by 3. That's the last operation done on the left side of the equal sign. So I can undo it by making it the first operation. Distributive property from the left is a valid operation. And in fact, I'm also going to distribute let me do one thing at a time. So I got 2 parentheses 3x minus 1 equals 3 parentheses x plus 2. And I can distribute now the 3 while I also distribute the 2. And I get that 2 times 3x is 6x minus 2 times 1 is 2 equals 3 times x is 3x plus 3 times 2 is 6. And now I could do eliminate more things. So I can eliminate the minus 2 by adding 2. And that does eliminate the minus 2. So that makes it simpler. 6x equals 3x plus 8. Subtract, and that's making choice 4 look really good. Minus 3x, subtract 3x. And I got that 6x minus 3x is 3x equals just a plain old 8. Divide by 3, and there's my answer. I got that x is equal to 8 over 3. And that would give me full credit in a part 2. So the answer is x equals 8 over 3, and we turned it into a passing problem. Just one number, one problem that I didn't turn into a passing problem, which I still gave you methods that you could still get it, right? I just didn't count it as a passing problem because guessing and checking could take a little while sometimes. And if you struggle with guessing and checking on that problem, it might take you longer than you prefer. That said, number 22, which equation represents the sequence 12, 6, 3, 3 halves, comma, dot, 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 where a1 is equal to 12? Is it a sub n is equal to 12 to 1 times 1 half to the n minus 1? Or is it a sub n is equal to 1 half to the n? Or is it a sub n equals 2 to the n minus 1? Or is it a sub n equals 12 times 2 to the n? Well, here I notice that I'm multiplying by a half. I could say dividing by 2, but since all of the answers are multiplying, I'd rather write it as multiplying by a half. Times a half, times a half, and then it's going to keep going. That's got to be the pattern. How do I know that this is the correct pattern? Because we humans are creatures of pattern. And because the test makers know that, they can't give you a pattern that's very clearly one thing, but secretly it's something else. So that this because it's the most obvious pattern, this is the pattern that they're referring to. Okay, so that means that the ones that have a half multiplication have to be are closer to being correct, and the ones that have a 2 multiplication have to be incorrect because the exponents are positive. Are greater than 0. In other words, it doesn't like turn the 2 to 2 to the negative 5 means 1 half to the 5th. So, but these exponents are not negative. So that eliminates 2, and we've clearly turned this one into a passing problem. Yay. So can I do this one on the calculator? Actually, I can. And I might even say I recommend it in this case. Enter. And I'm always going to choose choice 1. So I'm going to plug in 12 times parentheses, 1 half. How did that happen? Math number, enter, 1 half, close parentheses. Now I can't do n minus 1, but I could do x minus 1, x minus 1. And so the x coordinate is going to be the index n instead of an x. Instead of an n, it's going to be an x. And then the y coordinate is going to be the value. So if I go scroll, let's make sure, I'm going to zoom out a little bit. Let's see how this looks. I do need to zoom out a little bit more. It's going to be tiny, but we need to be able to see everything here. Okay. So, yeah, that's a little bit tiny, but we'll do what we can, right? Oops, I'm going to minimize that. I can make this just slightly bigger. Now, let's go to the calculator, and choice 1 for x equals 1 has y equals 12. For x equals 2 has y equals 6. 1, 2, 3. For x equals 3, the third one is y equals 3. And for the fourth one, we got 3 over 2. Number 1 choice 1 satisfies the conditions of the problem. Okay. Now there is a sequence. If I just may go to this, and just to be clear, a geometric sequence formula does appear at the end of the formula sheet. So we could have also done it that way. Okay. So the geometric sequence implies that we're multiplying by a fixed number. So that implies a sub n is equal to a sub 1 times r to the n minus 1. So the a sub n is equal to a sub 1, which is 12, times 1/2 to the power of n minus 1, which is exactly what choice 1 implies. Number 23, the axis of symmetry is x equals 2 for which quadratic function? Choice 1, which is a nice upward facing parabola. Choice 2, which is a table perhaps representing a parabola. Choice 3, which is j of x equals 2x squared plus 8x. Or choice 4, h of x equals h squared minus 4 8x plus 5. I again invite you always to do the problem on your own. You do need to know what the axis of symmetry is. What does the axis of symmetry do? It splits the parabola into two congruent halves. I know that congruent is a big people word. In fact, you'll talk about it a lot in geometry. Congruent just means the same exact shape, even if they're mirror images of each other. So I can explain it very nicely with choice 1. If I draw a vertical line directly through the middle of this parabola, and I'm going to redraw it so that it draws it nice and straight. There we go. Can I move it over a little bit? Let's see. Okay, so the notice where that vertical line is. That is the axis of symmetry. I'm going to try to move that over a little bit more. Notice where that axis of symmetry is, right? But the axis of symmetry is at x equals 1, 2, and 3. The axis of symmetry is at x equals 3, not x equals 2. So that axis of symmetry cuts the parabola, though the left and right half are congruent to each other. They look identical. Okay. Looking at choice 2, if you graph it, okay, I'm going to try to do the straight line. Good. And straight line. And if we graph this one, let's try doing a rudimentary graph here. -2, 6, -1, 3, 0, 2, 1, 3, 2, 6. So this one looks like very much like a parabola, and in fact it is a parabola. I can confirm by looking at the first differences or second differences, and it does have an axis of symmetry. But the question is, where is that axis of symmetry? That axis of symmetry is, and I'm going to highlight it in yellow this time because it's right on the y-axis. The axis of symmetry for choice 3 is the y-axis, which is x equals 0. And so that's not the correct answer. We now have a passing problem. So what about choice 3 and choice 2 and choice 4? These can be done by graphing them and looking for where the axis of symmetry is. But another way of doing them, and by the way, that's a recommended way of doing it, because if you do graph them, you could actually detect where the axis of symmetry is by sight, and only one of them is going to have the correct axis of symmetry. And sometimes the axis of symmetry is so far off, you know that it's incorrect. So what about, how do we get the axis of symmetry? Well, there's an equation of the axis of symmetry. And this is for an upward or downward facing parabola. X equals -b over 2a. Okay? Let's see. So if we apply that equation, to problem 3, choice 2, we have A equals 2, B equals 8, and C doesn't matter, but C equals 0 for the axis of symmetry doesn't matter. For choice 4, A is equal to 1, B equals -4, and C doesn't matter for the axis of symmetry, but C equals -5. Let's see. Axis of symmetry is equal to x equals -b over 2a, which again is equal to negative, in this case, 8 over 2 times 2, which is equal to -8 over 4, which is equal to -2. X equals -2. Whereas this one, and now I'm running out of space, but I'm going to write it in this color. X is equal to -b over 2a is negative of -4 over 2 times 1. And this is where it helps to use a calculator. Like if you don't know what -4 is equal to, the calculator will tell you. So if you struggle with basic arithmetic, this is an algebra test, not an arithmetic test. Just let the calculator do your arithmetic for you. -4 is equal to +4 over 2 times 1 is just 2. 4 over 2 is equal to 2, which is exactly what they wanted. Choice 4 is the correct answer. Now, jumping on to number 24. And by the way, number 24 is going to give us a perfect grade on the part 1. So this is actually super duper. I'm really excited. Number 24, each day a freight train passes by Anne's house. This freight train travels at 49 miles an hour. Each railroad car is 56 feet long. Which expression represents the number of railroad cars that pass by Anna's house per minute? Now, I'm going to give you something that'll give you a probable answer, but with more than 99% certainty on an Algebra 1 test. First off, we're looking for cars per hour, cars per minute, cars over minute. So this is what we want. Cars over minute. So a probable answer, which works because this is an Algebra 1 test, I can't predict what's going to happen in the future, but I can tell you that in 100% of problems that have been given in the past on the same exact topic in Algebra 1, the following method has worked. We can eliminate matching units in both the numerator and denominator. So they have to be matching units, and they have to be in both the numerator and denominator. So if we follow that rule, let's go to choice 1. We're not even looking at the numbers. This is a probable answer method. But if we look at choice 1, we see miles over hours times miles. Oh, look at miles and miles in both the numerator. They will not cancel, because they're both in the numerator. That's why. Choice 2, miles over hour times miles over feet. Oh, look at miles again. Both miles are in the numerator. They will not cancel. So choice 1 and choice 2 are incorrect. Choice 3, we got miles over hours times feet over miles. Now we have matching units in both the numerator and denominator. Okay. Maybe if I add the word appearing in both the numerator and denominator. Mile and mile appear in the numerator and denominator. They cancel. So we got over hour times feet times hour. Here's an hour in the numerator and an hour in the denominator. Matching units in both, appearing in both the numerator and denominator. They cancel. So we got feet over minute times car over feet. We got feet in the denominator, feet in the numerator. Matching units appearing in both the numerator and denominator. And we're left with cars over minute. This looks like the correct answer. And I will say this, I would have actually preferred this problem to be a little bit more difficult. And you might be hurt by saying, wait, Juan's saying he wishes that a test problem was a little more difficult. But the thing is that this is a problem number 24. Problem number 24 is supposed to differentiate between different levels of students, isn't it? So Number 24 could be made a little bit more difficult. Maybe the numbers don't appear in the right order, for example, the units don't appear in the right order, but maybe something, so one way or another, they could have made this more difficult, but still at the Algebra 1 level. But in 100% of problems that have appeared in the past, this has worked. And it seems that it's working so far with this one. Going to choice 4, we got miles over hours times feet over miles. Miles in the numerator, miles in the denominator cancel. So we got over hour times feet times minute over hour. There we go. Hour in the denominator, hour in the denominator. They will not cancel. They're both in the denominator. They will not cancel. Choice 3 is the only remaining answer. But if we had to do this one on a part 2, the way we could do it, we know that the cart is traveling at 49 miles per hour. Now, what we need to do, we need to convert this into cars over minutes. So let's see what they tell us, that each railroad car is 56 feet long. So I don't know how to convert to 56 feet yet. So I'm going to convert the miles to feet. Okay, and then the feet to cars. So how do I convert miles to feet? I put miles in the denominator and I put feet in the numerator. Okay, and on that note, we're going to do a quick check to observe, does the conversion between miles and feet appear in the reference sheet? And in fact, it does. Miles over feet. Okay, 1 mile is 5,280 feet. Okay. So 5,280 feet over 1 mile. And then now we can convert the feet to cars. Each car is 56 feet. So feet would go in the denominator, 56 feet, and 1 car in the numerator. And that converts feet to cars. That converts miles to feet and then feet to cars. Now we have to convert 1 hour to a number of minutes. So hour is going to be in the numerator and minutes is going to be in the denominator. And we're going to do the same check as we just did. We're going to check this to see if there's a conversion between hours and minutes, and there is not. And that confirms to us that we actually have to know that there are 60 minutes in an hour. 60 minutes is equal to 1 hour. And this multiplication would give us the correct answer. This doesn't appear exactly in the same order as choice 3, but if it were a part 2 question, this multiplying this out will give you the correct answer. So we now can circle choice 3 because it's a multiple choice question. And with that, we actually just got a perfect part 1, which is phenomenal. A perfect part 1, but not only a perfect part 1, but if you look on the rating guide, if perfect part 1 is 48 points, and 48 points is a 74, which is way past the 65. But this will be the first big lesson, well, not even the first big lesson, because we saw that a lot of part 1 problems are exactly like part 2 questions. And we're going to observe that even more when we go to part 2s and parts of part 3s and 4s. But this is yet another lesson on why saying let's focus on only the part 1s to pass this test is not the best advice. Or it's not, we need to expand on that. We have to focus on the part 1s by showing as much work as possible, which will then expand to getting way more points on the part 2s, which means that we focus on the whole test. Part 2s, 3s, and 4s. Now, why is this another reason to focus on both equally? Notice that a perfect part 1 is a 74, which means that if you did everything 100% perfectly, which means, and if you're the kind of student that struggles on part 2, 3, and 4, if you did everything perfectly on the part 1, you only get a 74, which means that you're not playing a game when you're focusing on the part 1s. You're not playing a game between 0 and 100. And we also talked about how wild guessing is technically a 45. So you're not playing a game of between a 45 and 100. You are playing a game of between a 45 and a 74. 74 is quite close to a 65. Focusing only on the multiple choice is not a sufficient strategy to guarantee a passing grade. You have to put work on the part twos. And the way you put work on the part twos is by putting the same focus on the part twos as you put on the part ones, which means showing work on every question. It's a big and difficult lesson to learn. I've heard a lot of teachers say focus only on the part ones. It's just not complete enough work. There is a piece of detail on the part two explanation. It does say you're going to have to write all sub formulas, substitutions, diagrams, graphs, charts, etc. There's one thing that it says, note that diagrams are not necessarily drawn to scale. This matters more for geometry students, but I have students cross out the words not necessarily and put the words almost, definitely. Almost definitely. So I have them cross out the words not necessarily and put almost definitely. The reason I recommend that, especially on the part ones, although it didn't come up for us, is that if you don't know how to do a problem, but then you just assume that it's drawn to scale when you have a diagram, you will be very likely to get the question right. That's super helpful on geometry, which is your next class. Not as helpful for algebra, but it is worth noting this is a diagram. It's because it's a graph, it's required to be drawn to scale. Okay? This is a graph. It's required to be drawn to scale. This is a box and whisker plot. It's required to be drawn to scale. So all diagrams, let's see if there's any other diagrams. This is another graph. It's required to be drawn to scale. So all graphs here are drawn to scale. All diagrams so far have been drawn to scale. We have to show as much work as possible. Number 25, a survey was taken to determine whether students preferred to watch videos or listen to music. Of the 100 students surveyed, 44 were seniors. Of the 65 students who preferred to watch videos, 42 were juniors. Use the information to complete the frequency table below. Basically, in most problems like this, if you get any additional number that requires arithmetic or math, you get a point. And then if you get all the numbers right, you get 2 points. So here's one that we have. Of the 100 student survey, so we know the total is 100. 44 were seniors. So in the seniors column, the total number of seniors is 44. Of the 65 students who preferred to watch videos, so the number of students who preferred to watch videos going to the right is 65. Of those who preferred to watch videos, 42 were juniors. 42 were of the watching video students were juniors. Use this information to complete the table below. Now, this one I will say that there is a certain amount of detail that they require to even get a point. But it's almost not worth saying this is the exact numbers you needed to get a point. Because the truth is, if you get, in most of these, if you get anything that requires math to get the answer, you will get 1 point. And if you actually commit an error along the way, but you get the rest of it, you use your error on the rest of it, you actually still can get a point. They allow for errors. So this problem, I've seen it left blank by students. Don't leave it blank. So let's see. How do I do this problem? I know that the total number of students is 100. The total number of seniors is 44. So I know that the total number of juniors is 100 minus 44, which is equal to 56. So I know the total number of juniors. Now I can get this number here immediately. I see the number of juniors who listen to music plus the number of juniors who watch videos is equal to 56. So the number of students who listen to music is equal to 56 minus the 42 who only watch videos, which is equal to 14. And 40, I'm going to just quick check. 42 plus 14 is 56. Good. Now, I know the total number of students is 100. The total number who watch videos is 65. So I can get the total number who listen to music is 100 minus 65, which is equal to 35. And that allows me to go now horizontally. So if the total number that listen to music is 35, of those 14 are juniors. So how many are seniors? 35 minus the 14 are seniors, and that's equal to 21. Okay? And finally, the number of students who watch videos is 65. Of those, 42 are juniors. So how many are seniors? 65 minus 42 is equal to 23. And you might have gotten some of these numbers in different ways than I did. The thing is that this problem only has 4 degrees of freedom. Junior versus senior times watch video versus listen to music. 2 times 2 is 4. So they have to give you 4 pieces of independent information, and they did that. When they give you 4 pieces of algebraically independent information, every other number can be calculated. Number 26, solve the inequality for y. 5 parentheses 2 minus y is equal to negative 11y minus 8. I would recommend solving this problem the same way you would solve any equation, but instead of writing an equal sign, you put the greater than symbol. And sometimes that's enough. This one was a little bit of a gift. Like I said, sometimes that's enough. They don't do one of the clever things that require you to switch the inequality symbol around. Like, for example, if you perform the action of dividing or multiplying by a negative number, you got to switch the inequality direction. Similarly, if you perform the action of changing the order of the inequality itself, put the left stuff on the right and the right stuff on the left, then you got to switch the order of the inequality. That's the main places where you switch the order of the inequality. In this case, I'm going to definitely... even if as a fake student, I don't know how to get the final answer, I know that I have to perform a distributive property because I need to get access to the y that's stuck inside parentheses. So I perform that distributive property. 5 times 2 is 10, minus 5 times y is 5y. Put the greater than symbol, negative 11y minus 8. Now I see that there's a y on the left side of the inequality and a y on the right side of the inequality. I'm going to get rid of the y on the right side of the inequality by doing the inverse of adding a negative 11y, which is adding positive 11y. I'm going to add 11y here too, and I'm going to combine like terms. I get 10. Now, minus negative 5 plus 11, according to the calculator, if you struggle with arithmetic, or according to my brain calculator, is 6. So negative 5y plus 11y is equal to 6y plus 6y. That's greater than negative 8. Now, the 10 is being added to the 6y, so I'm going to subtract it. Subtracting 10, and I see that 6y is greater than negative 8 minus 10. Once again, arithmetic. This is not an arithmetic. This is an algebra test. Let the calculator do the arithmetic for you if you struggle with algebra. With arithmetic. Let the calculator do the arithmetic for you if you struggle with arithmetic, and then focus on the algebra. Negative 8 minus 10 is negative 18. Divide by 6, because the y is being multiplied by 6. That's the inverse of multiplying by 6. So if I divide by that 6, cancel that out. There you go. I got that y is greater than negative 3. And that is a full 2 credit answer. Okay, number 27, express parentheses 5x minus 3 close parentheses times parentheses negative 2x plus 7 as a trinomial in standard form. I know people like FOIL, they like each with each. Each with each is the best method because it applies to more situations, and each with each boils down to the box method. So I am going to do this one by the box method. I'm going to make a box. Good. Make a vertical line here. Make a vertical line here. And I'm going to put the 5x multiplied by minus 3. And I'm going to multiply that by minus 2x and plus 7. And then I'm going to fill the box with the products of what's on the left and the top. Negative 5 times 2, negative 2 times 5 is negative 10. So negative 2x. And, oh, by the way, x times x is x squared. So negative 2x times 5x is negative 10x squared. Negative 2 times negative 3 is positive 6. Use your calculator to do the arithmetic. So negative 2x times negative 3 is positive 6x. 7 times 5x. 7 times 5 is 35. So 7 times 5x is plus 35x. And then 7 times negative 3 is negative 21. And now I'm going to add everything that's in the box. I got negative 10 x squared plus 35 plus 6 is plus 41. So plus 41x and then minus 21. Full credit answer. We are just cooking through this and getting points. I should say there are ways to get points out of some of these problems. I mean, here, if you just get as many numbers as you can get, you may find that you just get to the final answer. But if you get any numbers, you'll probably get a point. Here, if you just do your best, just eliminate numbers by using the same number with the inverse of the operation that was used with the number, you'll slowly get to the final answer, the correct answer. But if you struggle with that, just do what you think is right and make sure you continue to the end, and whatever you get is graded the way it is. One error, 1 point off, and you still get a point. Another thing that you could do, though, by the way, if you just state y is greater than 3, so get points. If you just state y is greater than 3, negative 3 rather, that's a point. So how could you possibly do that? You could do that by taking test values, plugging in test values for y, doing your best to guess, and one at a time. Eventually you get to the point where you find that the left and the right are actually equal to each other at negative 3. And you find that like 0 is part of the solution set, so everything to the right of negative 3 is a solution, but negative 3 itself is not a solution. So you write down y is greater than negative 3 just by guessing and checking, and you get your point, a single point. A single point is half a multiple choice question. So is it worth your time, if you don't know how to do this problem at all, to do that with by guessing and checking? Yeah. But I would actually advise to do as much just absolutely correct math as you can do. Never lean towards the stuff that you know is incorrect when you have anything left at all that you know is correct. Like maybe you didn't know that you could add 11y, but you knew that you could add 8. Add the 8 instead. Focus on that. Maybe you didn't know, well, you would get something else. The point is, always gravitate towards the thing you know is true, and you'll get your points. This one can be done if you do a little bit of, like, if you don't know how to do the multiplication, you could by the box method, which I highly suggest knowing how to do, because that's a basic operation in Algebra 1, Geometry, Algebra 2. But what you could do, you get the 5x times negative 2x is negative 10x, plus a blank times x. Maybe you don't know what the blank is. And then minus 3 times 7 is minus 21. So you know that this is true. And then you might be able to guess at numbers for the coefficient of x, plug in some basic x values into this and this, press the y equals, and then every time you get the answer wrong, you just change the coefficient of x until you eventually get it right. And then you state negative 10x squared plus 41x minus 21. And even if you don't know how to do it, that will be a point. I want to point that out again. All answers, where is it? For all questions on this part, a correct numerical answer with no work shown will receive only 1 credit. But 1 credit is greater than 0. So if you just get the answer, you get a point. It turns out that this one, the work that we do to get the 8th answer is enough work to get the two points. So we have to, this is the first and fourth term of an arithmetic sequence are given below. Negative 20, comma, blank, comma, negative 2. Determine the 8th term. So what we can do, so this is adding a fixed number, adding the same fixed number, adding the same fixed number again to get to negative 2. I noticed that to get from negative 20 to negative 2, I can add 18. So if I add 6, add another 6, add another 6, I can get to negative 2. That's my sleep alarm, but I'm working for you. So I'm not going to bed until this video is done. I can get the fourth term. So by the way, negative 14, negative 8, negative 2. I can just add 6, but add 6, and then one more time, add 6. I do want to count. I've seen so many students get the question wrong by not counting right. This is the first, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth. So don't count incorrectly. Do all the correct math and then not count or not bother to count and get the incorrect answer. Let your calculator let you know what negative 2 plus 6 is, and that's 4. And 4 plus 6 is 10. 10 plus 6 is 16. 16 plus 6 is 22. So now I could do 22. That's actually 2 points, not just 1. And so that is a perfectly valid way of doing the problem. You could use from the formula sheet, there is an arithmetic sequence formula, and that is a perfectly legal way to do it. And I don't want to point out again, it is on the formula sheet. Here's the arithmetic sequence formula, so you could use that freely. So the way to get points on this one is also just the way to get all the points, which is great. That's rare, but it's great. Okay. Number 29, write an equation in slope-intercept form for the line that passes through negative 2, 5 and has a slope of negative 3. Use the set of axes below. Use of the set of axes below is optional. Okay, so I am going to use the axes below because, well, one, it does help, but two, you kind of just need to know how to graph equations, linear equations especially, but in problems that require the line, like later on, and get you 2 credits. So it passes through negative 2, 5, negative 2, 1, 2, 3, 4, 5, and has a slope of negative 3. So the rise over the run, delta y over delta x, that's equal to negative 3 over 1. So I graphed the point negative 2, 5, and now I got to go rise over run negative 3 over 1. So down 3, I'm going to do it in a different color too. Down 3 over positive 1, down 3 over positive 1. And that gives me the y-intercept. I mean, look at the benefits of doing this. Down 3 over positive 1, down 3 over positive 1, down 3 over positive 1. Okay. Now, from the green point, also, negative 3 over 1 is also 3 over negative 1. So I could go up 3 over negative 1 and up 3 over negative 1, so something like there. And now I got to connect this line with a straight edge. I got to actually draw this with a straight edge. Okay. So I am going to do that. Now, your straight edge is actually a physical object. My straight edge is the software. Nice. Okay. So let's see. Yep. Okay. I don't like the way that looks. Let me try one more time. I don't like the location of that. So let's try again. Is it not going to give it to me? Nope. Try it again. Okay. Passing through all the points carefully. There we go. Okay. So, and now I can put an arrow over here, and I could put an arrow over here. This is a function that goes past the edges, and it legally is allowed to go past the edges. So I do go past the edges, and I also put an arrow at the end. Now, I see the y-intercept, and that tells me what the value of b. So y is equal to mx plus b. Let's not forget that. Y is equal to mx plus b. M is equal to negative 3, and b is equal to negative 1. So if you write y equals negative 3x minus 1, you've got full credit. If you decided to do this in point slope form, So this is a slope-intercept form. If you decided to do this in point-slope form, it's y minus y1 is equal to m parentheses x minus x1, and that's totally legal. You could have just done it that way, and that would have, they didn't, oh, they did say in slope-intercept form. I apologize. So I'm gonna cross that out. Actually, not gonna cross it out, because you could get the slope-intercept form by solving for y. Y minus the y coordinate that they gave us 5 is equal to the slope -3 parentheses x minus the x coordinate that they gave -2, so +2. And if you now distribute and solve for y, you do get y equals -3x plus 1. Okay? So we get two ways of doing that problem. Number 30, factor the expression x cubed minus 36x completely. I've seen a lot of students who don't know how to factor this get this right, because they guess at what the factoring is based on their own personal intuition, and they get it right. One thing is that all the terms have an x. So my advice is factor correctly. And I'm telling you to factor correctly, and you might be struggling with the problem, but factor correctly as much as you can. You might get a point. A point. Another method, if you factor correctly as much as you can, but also guess and graph your guesses, and y equals x cubed minus 36x, and then we compare, or compare the table also, you can get 2 points out of this. By, for example, I've seen a lot of students know how to do the first step, and then it turns out that the second step is just done, and so they get the answer right. That's what I've seen. 2 points. So here I see both terms have an x, so I can factor an x to the first, and the factor pair of x and x cubed is x to the second, minus the factor pair of x in 36x is just 36. And so that's already basically a point. And now this x squared minus 36x, this is a difference of 2 squares. Or DOTS, some teachers like. Some teachers also like DOPS, DOPS, difference of perfect squares. If you have p squared minus q squared, we talked about this factorization earlier in the test. That's equal to p plus q times p minus q, where what takes the role of p and q? P is equal to x and q is equal to 6. So we do get that initial x, which is that, and then the x squared minus 36x, 36 is 6 squared. So we got x plus 6, x minus 6, and that is a full credit answer. 2 steps, done. So if you could get the first step, and then you do some comparing and guessing, and then just write down the correct answer based on comparing and guessing on the y equals calculator, you can get 2 points on that one, which is phenomenal. And with that, we actually just aced the part 2s, which is phenomenal. We aced the part 1s and the part 2s. Notice, I do want to point out something though, how important it is to focus on the part 2s, 3s, and 4s. We said that if you focus on only the part 1s, if you get every multiple choice correct, which is, if you're not showing all work, you're not getting all the multiple choice correct. Doing all the multiple choices, sorry, I blanked for it. So doing all the multiple choices, getting them all correct, that's 74. Then if you get every single part 1, part 2 right, we're still not at an 80. We only gained 5 more points. That's pretty harsh, yes, but it means that we have to put a lot of focus on the entirety of the part 2s, 3s, and 4s. That's a big lesson for us. One more point and we're going to get an 80 on this Regents. And this is a 4-point section. And once again, a correct numerical answer with no work shown, it will receive only 1 credit. And of course, we said that diagrams are almost definitely drawn to scale. This problem, just like the previous problem, had a graph paper. Graph paper is necessarily drawn to scale. So this one says to graph f of x equals negative 3x and g of x equals x squared on the same set of axes. So you can make a table of values if you want, or you can go by the slope-intercept form. M equals negative 3 and b is equal to 0. I actually do recommend, let's pull out the calculator here. I do recommend, I'm going to unhighlight this equal sign so we don't look at the values. Oh, here, negative 3x. And the other one is y equals x squared minus 2, x squared plus 2 rather, x squared plus 2, which interestingly, that exact function did appear in a previous example. That table, which had a quadratic in it, was x squared plus 2. So if I graph them, I now, let me do zoom standard, I'll know what my graph is supposed to look like. And it looks like they cross somewhere here, which is interesting. It's hard to kind of tell exactly where they cross. And now if I go to the table is going to give me what numbers I can graph. Now, moving the calculator over to the left a little bit so that we could see the numbers a little bit, or using the slope and intercept, I see, well, it passes through the origin 0, 0, right? Over here, 0, 0. But also if you go to the left, negative 1, 3, negative 2, 6, negative 3, 9. And then if you go to the right, 1, negative 3, 2, negative 6, and 3, negative 9. Now the y-coordinate, the next y-coordinate is 4, 12. It's going to be somewhere up here. So I'm going to draw a straight line. Perfect. So my straight edge is the software. Your straight edge is a ruler. You are required to use a straight edge to draw straight lines. So this is going to continue past the edges. So I'm going to put arrows there too. And I'm going to label this down here somewhere, y equals negative 3x. Generally speaking, if there's 2 graphs on the screen, you are supposed to label these. Even if there's an extreme situation where there happens to be a graph that they don't expect you to label, like there's 2 graphs and they don't expect you to label it, I would recommend not getting into the habit of saying, wait, which ones do I have to label, which ones don't I? Follow this rule. If there are 2 graphs, label the graphs. That's it. If there's 1 graph, you don't have to label it. But if there's 2 graphs, you have to label it. Follow that rule and you're all set. This one, y equals x squared plus 2, is the magenta table here. And I see, let's see, negative 4, 18, that's beyond the graph. Negative 3, 11, which is slightly above. And then negative 2, 6 happens to cross right over here. And don't want that deleted. Negative 1, 3 is also on that parabola. Don't want that deleted. 0, 2, 1, 3, 2, 6. That should look familiar. Again, we graphed that exact same parabola in a previous multiple choice question today. And then again, so 3, 11. So this parabola, I am going to carefully trace this. Very unlike the line, which I let the software straighten it for me. I'm going to carefully trace this. I'm going to keep going. Won't cross x equals 3, y equals 10, because at x equals 3, y is 11. It's above. So I pass that around there, and I put an arrow here, an arrow here, and I label this one as y is equal to x squared plus 2. And that's 2 points. That's a 2-point graph. Then the next question, to state the values of x that satisfy the equation f of x equals g of x. What's lovely about this question is they only ask for the x coordinates. And if you did what I did and put this into y equals, the problem says state. It does not say calculate or verify or justify. It just says state the numbers, which means we could state the numbers. I noticed that for x equals -2, the y coordinates are equal. And for x equals -1, the y coordinates are equal. So if you type in as your answer, let me minimize this now. X equals -2, and I'm sorry that I blocked this off. And also x equals -1, then you get full credit for that part. This is a 4-point problem. We only needed one of the points to get an 80. And there's a lot of places where you can get the points. I mean, literally plug it into your y equals, get the table of values, graph the points, and also state the values of x that satisfy f of x equals g of x, get that from the table. You can get 4 points on this one, even if you feel like you don't know how to do it, as long as your graph is neat enough. That's really the only requirement. Now, to be clear, handwriting can be as sloppy as you want it to be, but neatness on graphs is actually required. You're not allowed to be not neat on graphs, because the thing is that the exact location of points matters. You see how this point is on the origin? If I drew it to the left, right, up, or down from the origin, but it's supposed to be at the origin, I'm wrong. There's a little pixel where these two black lines cross, and that pixel is not even visible because it's covered by this giant red dot. Graphs have to be neat. Number 32, using the quadratic formula, solve 6x squared plus 2x minus 1 equals 0, expressed in simplest radical form. So this problem does require us to use the quadratic formula. So we're going to go to the formula sheet just to confirm, yes, they do give us the quadratic formula. So I would go to that formula sheet and get the quadratic formula and then copy it directly onto this test. It's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And then we make sure we identify a, b, and c. Now, they did make this problem somewhat simple. They put it in standard form for us. If this wasn't in standard form, you put it in standard form, and then you write a equals 6, b equals the coefficient of x is 2, and c is the constant coefficient, -1. And you plug those numbers in with careful parentheses, equals -2 plus or minus the square root, the number 2 squared. That's another thing they often do. They make b negative to check if you remember to put b in parentheses, a negative number in parentheses, but they didn't do that. -4 times a is 6 times c is -1. Let's extend this radical. All over 2 times 1. All right, so then now this, and I want to be clear, this is not an arithmetic test. This is an algebra test. So you should actually plug in, if you want the full credit. Let's see if I can get the calculator showing the full radical. Let me move this over a little bit. You should plug in, okay, the 2 squared, the 2 squared minus the 4 times 6 times the -1. Let the calculator do that for you, okay? You don't have to do step-by-step arithmetic. You are legally allowed to let the calculator do the arithmetic for you. So this is equal to -2 plus or minus radical 28 over 2. Now I have to check this. Let's just be clear. They did say simplest radical form. This is something that they used to test for when I was a kid, and for some reason they stopped testing for it, and now they're testing for it again. So what are we gonna do? We are gonna um, simplify the radical like we did in the previous problem. Radical 28, we find the greatest perfect square factor of 28 for radical simplification. Radical 4 times radical 7. Radical 4 times 7 is 28, so radical 4 times radical 7 is radical 28. Radical 4 is 2, and the radical 7 just stays radical 7. So this is equal to negative 2 plus or minus 2 rad 7 over 2. And believe it or not, at this point, they actually gave full credit for this answer. So you could theoretically stop there. But if this were another part, if they, for example, said simplest form, there is one more simplification that can be done. We could divide by 2. And if we divide by 2, we get a 1 here. Let me put this in green. We get a 1 here. The negative 2 times divided by 2 is negative 1. And the 2 times divided by 2 is 1. So we do get negative 1 plus or minus 1 radical 7 over 1, also known as negative 1 plus or minus radical 7. Either one of these answers would have been valid. And I want to delete the elimination algebra. Oops. I want to delete the elimination algebra just because since this is a valid answer, I do want you to be able to see it. Okay. There we go. And that's full credit. All right. I'm pretty excited. We got 3 more problems. 3 more problems. Interestingly, we got 3 more problems and we're not yet at a 90. We're not yet at a 90. So that's I feel like it's interesting. It's like, how many points do we need to get a 190? So you see how every single extra point above a 65 is actually difficult to get. And so if you're playing the game of just passing and you're focusing on only the multiple choice, that's a risky choice. You saw how some of these questions are multiple choices. Look at this. They could make this into a multiple choice and say, what is the solution to the equation 6x squared plus 2x minus 1 equals 0? And the multiple choices would be negative 1 plus or minus radical 7, or other things that are not correct. Easily part 2s, 3s, and 4s can be converted to multiple choice. Number 33, the table below shows the price of a new cell phone and the length of time in months since its release. And I see the time release 06912 and the price in dollars 1200 down to 920. State the linear regression equation for this set of data. Round all values to the nearest hundredth. State the correlation coefficient of this data rounded to the nearest hundredth. And also state what the correlation coefficient indicates about the linear fit of the data. It's almost guaranteed that the answer to the last piece is strong. It's been a long time since I've seen a correlation coefficient question where the answer wasn't just strong. So unfortunately, I got to make the calculator tiny, but I'm going to do that in a second. First, I'm going to turn the calculator on. You have to turn diagnostics on. There are many ways to turn diagnostics on, for example, going to the mode, but not every calculator that you'll be able to use has that. But the diagnostics on, you press catalog, and you scroll all the way down. You keep using the arrow to scroll all the way down to D. Diagnostics on, press enter, 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 done. Okay, now diagnostics are on. Okay, now to edit, to create a list, press the stat button here and edit. Now this is where I'm going to make the calculator smaller so you and I both can see the numbers. So the x coordinates are 0, 3, 6, 9, 12. And then the y coordinates are 1200, 1150, 1100, 1000, and 920. Okay. So now we've got to get a linear regression equation. How do we get the linear regression equation? We quit this. So the first thing I do before even getting that, I type in the numbers first, and then I check if I typed them correctly. Don't like type them and check simultaneously. It just overloads your brain. Trust me, it makes students type it incorrectly. Type it first and then check. So 0, 3, 6, 9, 12, 0, 3, 6, 9, 12, and 1200, 1150, 1200, 1150, 1100, 1000, 1100, 1000, and 920, 920. So now we quit, and now we press stat, calc, for calculate, linear regression equation in the form mx plus b or ax plus b, enter. List 1 is the x coordinates, list 2 is the y coordinates. There is no frequency list. I am going to store the regression equation because that is a very helpful feature in many tests. Vars, y vars, but this is just an extra little bit of knowledge. Y vars, function. I'm going to store it as y6 because I think that one's blank, but if it's not, something got deleted. Oh well. Enter, enter. And we have these numbers. Okay. So now, having these numbers, I bring that to the calculator. What I recommend to students is actually put all the digits and then round. Again, put all the digits and then round. And you might say, and teachers might say, wait, is it really worth your time to put in all of the digits? Yeah, it is. Because the amount of time it takes to type those digits and then check to see that you rounded correctly is a huge muscle memory fixer. And it makes it more guaranteed that you don't lose points for silly things like, oops, I didn't round to the correct number of decimal places. So I got y is equal to ax plus b, b, where a is equal to negative 23.6666 repeating, and b is equal to 1216 exactly, and then r is equal to negative 0.9891688,273. So I could round now to the nearest hundredth. So that's what I do. I write all the digits and then I circle the rounding that they want me to do. And so I get y is equal to, a is negative 23, negative 23.6. The next 6, the 6 after the 6 is a 6. That causes us to round the 6 to a 7. X. Why am I writing so far to the right? Let me rewrite this. Y equals negative 23.6. Then this is the 6 that we got to round. This 6 causes us to round up to 7. X plus 1216. That's an integer, so I don't have to round that one to the nearest hundredth. It's already rounded to the nearest hundredth. And then they state the correlation coefficient to the nearest hundredth. Same deal. I wrote all of the digits, and now the muscle memory fixer, I just circled the nearest hundredth, and I write negative 0.9, the 8, the 9 causes us to round up, so 9, 9. And that's 3 points so far. And if you state, so because the correlation coefficient is between 0.7 and 0.1 in absolute value, there is a strong correlation. So if you just write the word strong correlation, or it's just the word strong, in fact, they give you the points. Strong correlation. Okay? If you just write the word strong, that's the point. They don't expect full sentences. And if R is really close to 1 or -1, write the word strong, you get a point. Let me minimize this calculator now. Let's go to number 34. 2 points away from a perfect grade on this region. So I'm like really super excited. Solve the following system of equations algebraically for all values of x and y. Y equals x squared plus 9x plus 4 and y minus 2x equals -6. Now this is a skill that they're really emphasizing now on the Regents, being able to solve systems of equations algebraically. And when one of them is a quadratic. So how am I going to solve this one? I prefer to solve this one via substitution. I'm going to solve for y by adding 2x and adding 2x. And I get, for the second equation, I get that y is equal to 2x minus 6. And I'm going to substitute that into the first equation. So I got, since y is 2x minus 6, like instead of y, I could write 2x minus 6. That's equal to x squared plus 9x plus 4. Now I'm going to subtract 2x. And if you're comfortable with it, you could simultaneously do this plus 6. But if you want to eliminate this minus 6, but if you want, you can wait till the next step. But this eliminates the minus 2x. This eliminates the plus 2x. This eliminates the minus 6. And we get that 0 is equal to x squared plus 7x plus 10. Now, how am I going to do this? I've already used the quadratic formula. You are allowed to use the quadratic formula, but because I've already done one that way, I'm going to use the factor rainbow. So I need to have that blank. Well, first off, a is equal to 1. So this method works when a is equal to 1. Blank plus blank equals b, 7. That's b. And blank times blank, the same two numbers multiplied to 10, which is c. And I actually look for the product first. 1 and 10 multiplied to 10. 2 and 5 multiplied to 10. 3 is not a factor of 10. 4 is not a factor of 10. 5 is already on the list, so I've got the full factor pairs that multiply to 10. And in fact, if I get a positive 2 and a positive 5, they add up to 7. And a positive 2 and a positive 5, they add up to 10. This is yet again another situation where they're actually mixing up sometimes the number being all positive or sometimes the number being all negative. In previous Regents, they would make sure that they actually tested that skill that a lot of students struggle with, which is adding and subtracting and multiplying and dividing with both positive and negative numbers. In this test, they really skipped a lot of that stuff. All right, 2 and 5 plus 5 is 7. 2 times 5 is 10. So now I can immediately split this into parenthesis, x plus 2 and x plus 5. Where did 2 and the 5 come from? This 2 and this 5. That's why we bothered doing it. So now I gotta the zero product property states that this product is equal to 0, therefore one of the factors is equal to 0. So I could say x plus 2 equals 0, solve that by minus 2, and I get that x is equal to -2. Okay, and I'm gonna have to get a y coordinate. X plus 5 equals 0, minus 5 minus 5, and I got that x is equal to -5. And with each of these x coordinates, I'm gonna get my y coordinate by using the easier equation, I think, in my opinion, the second equation, or the modified second equation. Suppose you made an error in modifying the first equation. If you use the first equation, the modified first equation, no, I'm sorry, the second equation. If you use the second equation and get it right, great. If you actually made a mistake in modifying the second equation, let's say some weird arithmetic error, but you verify with the modified second equation, you still get the point. So you only lose 1 point for making that first mistake. You don't lose it for making the same mistake twice. So I am going to use the y equals 2x minus 6, even though strategically speaking, there's a benefit to plugging into both original equations. So I'm going to plug into the y equals 2x plus 6. So I got y is equal to 2 times -2 plus 6. And I let the calculator be my arithmetic calculator. did I say plus 6? I meant minus 6. So -4 minus 6 equals -10. So I got one solution, is the point -2, -10. And then the second solution, I got y is equal to 2 times -5 minus 6, which is equal to -10 minus 6, which is equal to -16. So my first solution is that, and my second solution is -5, -16. And that's 4 points. And yet, I didn't have a 90 until problem 34 of 35 gave me the 90. That's pretty crazy. I needed 34 problems, mostly 100% correctly, nearly 100% correctly, to get a 90 on this Regents. Or, a smattering of points lost here and there. If you look at the conversion chart, to get a 90, I needed 75 points. Problem 35 is 6 points. That brings us down to 76 points if we don't do it at all. And so every point except one from problem 34 gave us the 90. So we actually now have a 91. But if we now get problem 35 correct, we get a perfect grade. Note that diagrams are almost definitely drawn to scale. And this is in fact a diagram of a graph, so it is drawn to scale. And that's the last diagram. So every diagram on this test was drawn to scale. Number 35, Sarah earns $6 per hour babysitting and $12 per hour tutoring. Her goal is to earn at least $120 per week. Sarah is allowed to work a maximum of 14 hours per week doing both jobs. If X represents the number of hours Sarah babysits and Y represents the number of hours she tutors, write a system of inequalities that could model the situation. And then we have to graph it. But let's focus on that part. I recommended earlier writing a verbal inequality, and that's what I'm going to recommend again. So this says that she makes $6 an hour babysitting, $12 an hour tutoring, and her goal is to earn at least $120 per week. And she works X hours babysitting, and she works Y hours tutoring. So I'm going to state that the money earned babysitting plus the money earned tutoring is equal to that's equal to the total amount she earns, and that's got to be at least 120, so greater than or equal to 120, which is equal to 120. So how much does she earn babysitting? Now, the following is a skill that I really do need you to have. It's a basic skill that you need to know that repeated addition of a number is multiplication. So 7 plus 7 plus 7 plus 7, I just added 7 4 times. That's 7 times 4. You actually just need to know that. 9 plus 9 plus 9 plus 9 plus 9, I just added 9 5 times. That's 9 times 5. You do need to know that. I don't care that it's 45. I care that you know that 9 plus 9 plus 9 plus 9 plus 9 is 9 times 5. I care that if I'm adding the numbers, the number 11, 7 times, that 11 plus 11 plus 11 plus 11 plus 11 plus 11 plus 11, I care that you know that that's 11 times 7. I don't care that you know that it's 77 because the calculator can handle that, but you do need to know that that would be 11 times 7. When you're adding a number repeatedly, that's equivalent to multiplying by how many times you're adding it. That is just algebra necessary skill. Here is where we're going to use it. How much money does she make babysitting? Well, 1 hour of babysitting, $6. 2 hours of babysitting, that's 6 plus 6, 6 times 2. 3 hours of babysitting, that's 6 plus 6 plus 6, that's 6 times 3. 4 hours of babysitting, that's 6 plus 6 plus 6 plus 6, or 6 times 4. So 5 hours of babysitting, 6 times 5, 6 hours of babysitting, 6 times 6, 7 hours of babysitting, 6 times 7. So if it's X hours of babysitting, we're repeatedly adding 6 X times, which is equivalent to multiplying 6 times X. How much she makes tutoring. 1 hour of tutoring, 12. 2 hours of tutoring, 12 plus 12. 3 hours of tutoring, 12 plus 12 plus 12, which is 12 times 3. 4 hours of tutoring, 12 times 4. 5 hours of tutoring, 12 times 5. So Y hours of tutoring, 12 times Y. Because that's adding 12 repeatedly, Y times. That's the same as 12 times Y. And that's greater than or equal to the total, 120. And we've got 1 point, and we've got 5 points left on this Regents, which is great, to get 100. To get 100. Could you imagine how awesome it is to get 100 on a Regents? It looks great on your transcript. Colleges love to see it. If you're fighting for that 100, this word inequality method or this word equation method, phenomenal. Because the next inequality that I got to write is the one for a number of hours a week. So I'm going to write a word equation, the number of hours babysitting plus the number of hours tutoring. That's got to be greater than or equal to the max, the max hours is equal to 14. So that's got to be greater than or equal to 14. I don't like the fact that I wrote the word total here. I'm going to replace the word total here for the first inequality with max min. Oh, and I messed up that inequality, didn't I? The min money, which is equal to 120. Here, the maximum number of hours, we're working 14 hours or less. This one is, so this is a mistake, but I'm correcting it. So less than or equal to the max hours, which is equal to 14. So the number of hours babysitting they said is X, plus the number of hours tutoring is Y. That's got to be less than or equal to 14. And now we have 2 inequalities, 2 points. We've got just a phenomenal grade on this Regents. I'm really loving the way things are looking. The next one, on the set of axes below, graph the system of inequalities that you wrote. And you could do this one by solving for X, solving for Y in the first inequality, and then graphing on your graph page, on your calculator. Just press Y equals, right? But there's a way to do this one without doing that I actually recommend. Since these are linear functions, it's actually good to just calculate the value when X equals 0 and calculate the value when Y equals 0. So when X equals 0, Y is less than or equal to 14 for the green one. And when X is equal to 0, when Y is equal to 0, X is less than or equal to 14. And since this is a linear function, and it happens to be less than or equal, so equal is okay, we're going to draw a solid line. Okay. So we drew the solid line, and now this is less than or equal to, so it's 14 hours or less. So we're going to shade below this green line. The way we shade below this green line is by doing these nice little diagonal hashes. Try to get all the way to the edge. Light diagonal hashes. There we go. And now the first inequality, which was the more difficult one. Oh, by the way, we got to label this one. We're going to label it in a second. So it's 1 point for graphing correctly, 1 point for labeling. If you don't label, you lose a point, which I think is insane. But if X is equal to 0 for the first inequality, but then we got 12Y is greater than or equal to 120. So y is greater than or equal to 10. Do I want to do it in this color? I don't. I want to do it in this color. And then if y is equal to 0, 6x is greater than or equal to 120. Divide by 6, so x is greater than or equal to 20. And now I'm going to draw the straight line from this point to that point. Okay. And this one, again, is a solid one because the amount of money has to be greater than or equal to. She wants to earn at least $120. Not more than 120, but at least 120. So now we have to earn $120 or more, which means more hours of each allows us to make more money. So now we shade above and we do hash marks again. Okay. You could draw these pretty light. You can shade, and your graphs need not be drawn with pen. You could draw these with pencil. You can shade, but I think it gets a little bit confusing. And so now that's still, all of that is still only a single point. We have to label. So this first inequality was 6x plus 12y is greater than or equal to 120. And the bottom inequality, I almost want to rewrite that in a darker color, in a different color specifically. I'm going to rewrite it in red. In red. Select the red. There we go. 6x plus 12y greater than or equal to 120. And then the bottom inequality was x plus y less than or equal to 14. Okay. Now, they did not expect us to label the solution set, but if they did ask us to label the solution set, we could put a big fat S there. But what they do instead, and we've already gotten 2 points for that. Now that's 4 points. We're about to finish problem 35. We're about to do our mic drop that we do with now base. It's become tradition for us on every video. We're going to finish number 35. We're going to pick up the mic. We're going to drop the mic and we're going to say bye. And that's it. And I want to congratulate you for getting to this point because it means that you are dedicated to doing the best that you can on this Regents. And I'm really proud of you for that. My recommendation, believe it or not, if you're a struggling student who is just trying to get their 65, my recommendation to you is actually to print exactly this Regents. Do the entire Regents without any videos. Don't check your answer. Especially don't check your answer because you need to use strategies to try to eke out every point possible, including the guessing strategies, eliminating the incorrect answers, guessing and checking, plugging in test points. Every strategy, we did a lot of strategies on this test. The 2x2 problems, a lot of strategies on this test. Using all of those strategies, you could eliminate a lot of choices, even questions that you don't know how to do. And there's a lot of problems that even on the part 2s, 3s, and 4s, guessing and checking could get you a point, which is a big deal. Okay. We are now going to finish the problem by stating a combination of hours babysitting and tutoring that would satisfy the situation. Justify your answer. So any point in the combined solution set is a valid answer. These are both solid lines because less than or equal to and greater than or equal to cause us to draw solid lines. So any region in this triangle, any point in this triangle is a valid answer. For example, I see this point here, which is the point 1, 11. So I'm going to go here and say, let's say, what does 1 and 11 represent? 1 represents the number of hours babysitting and 11 represents the number of hours tutoring. So 1 hour, let's go again, babysitting. And 11 hours tutoring. And now this one says to justify our answer, and we do have to justify our answer. And the way I'm going to justify it is using the graph, because the point 1, 11 is in the, we're about to drop the mic, solution set. Put a period there. We're going to pick up the mic. We're going to drop the mic. We just got 100 on this Regents. Congratulations. Thank you for being with me, and I'll see you in the next video.